What's going on, everybody? Welcome back to another video. Today, we're going to be learning the basics of Python in under 3 hours. Python is a fantastic skill to know how to do, but I remember when I was first learning Python, it was a little bit intimidating. It was a little bit more difficult than I was used to when I had just known Excel and SQL, and Python seemed really difficult. But I've been using Python for over 7 years now. It is a fantastic skill to know how to use. So in this really long lesson, we're gonna be walking through everything you need to know in order to get started in Python. I'll be walking you through how to set up your environment to make sure that you can actually run your code, and then we'll be walking through all of the basics, all the variables and for loops and while loops and even web scraping, and we'll even have a full project in this as well. So we have a ton of things to cover, and I hope it is really helpful. Without further ado, let's jump onto my screen and get started. All right, so let's get started by downloading Anaconda. Anaconda is an open source distribution of Python and R products. So within Anaconda is our Jupyter notebooks, as well as a lot of other things, but we're gonna be using it for our Jupyter notebooks. So let's go right down here, and if I hit download, it's gonna download for me because I'm on Windows. But if you want additional installers, if you're running on Mac or Linux, then you can get those all right here. Now, if you are running on Windows, just make sure to check your system to see if it's a 32-bit or a 64. You can go into your About and your system settings to find that information. I'm gonna click on this 64-bit. It's gonna pop up on my screen right here, and I'm gonna click Save. Now it's gonna start downloading it. It says it could take a little while, but honestly, it's gonna take probably about 2 to 3 minutes, and then we'll get going. Now that it's done, I'm just gonna click on it. And it's gonna pull up this window right here. We are just gonna click next because we want to install it. This is our license agreement. You can read through this if you would like. I will not. I'm just gonna click I agree. Now we can select our installation type, and you can either select it for just me, or if you have multiple admin or users on one laptop, you can do that as well. For me, it's just me, so I'm gonna use this one as it recommends. Now it's gonna show you where it's installing it on your computer. This is the actual file path. It's gonna take about 3.5 gigs of space. I have plenty of space, but make sure you have enough space. And then once you do, you can come right over here to next. And now we can do some advanced options. We can add Anaconda 3 to my path environment variable. And when you're using Python, you typically have a default path with whatever Python IDE or notebook that you're using. I use a lot of Visual Studio Code, so if I do this, I'm worried it might mess something up, so I am not gonna do this. It also says it doesn't recommend it. Again, messing with these paths is kind of something that you might wanna do once you know more about Python, so I don't really recommend you having this checked. We can also register Anaconda 3 as my default Python 3.9. You can do this one, and I'm gonna keep it this way just so I have the exact same settings as you do. So let's go ahead and click install. And now it is going to actually install this on your computer. Now, once that's complete, we can hit next. And now we're gonna hit next again. And finally, we're gonna hit finish. But if you want to, you can have this tutorial and this getting started with Anaconda. I don't want either of them because I don't need them. But if you would like to have those, keep those checked and you can get those. Let's click finish. Now let's go down and we're gonna search for Anaconda. And I'll say Anaconda Navigator. And we're gonna click on that. And it should open up for us. So this is what you should be seeing on your screen. This is the Anaconda Navigator. And this is where that distribution of Python and R is going to be. So we have a lot of different options in here, and some of them may look familiar. We have things like Visual Studio Code, Spider, RStudio, and then right up here, we have our Jupyter notebooks. And this is what we're gonna be using throughout our tutorials. So let's go ahead and click on Launch. And this is what should kind of pop up on your screen. Now, I've been using this a lot. So I have a ton of notebooks and files in here, but if you are just now seeing this, it might be completely blank or just have some, default folders in here. But this is where we're gonna open up a new Jupyter notebook where we can write code and all the things that we're gonna be learning in future tutorials. And you can use this area to save things and create folders and organize everything. If you already have some notebooks from previous projects or something, you can upload them here. But what we're gonna do is go right to this new. We're gonna click on the drop down and we're gonna open up a Python 3 kernel. And so we're gonna open this up right here. Now right here is where we're gonna be spending 99% of our time in future videos. This is where we're gonna write all of our code. So right here is a cell, and this is where we can type things. So I can say print, I can do the famous hello world, and then I'll run that by clicking Shift Enter. And this is where all of our code is going to go. These are called cells. So each one of these are a cell. And we have a ton of stuff up here, and I'm going to get to that in just a second. But one thing I wanted to show you is that you don't only have to write code here. You can also do something called Markdown. And so Markdown is its own kind of, you could say language, but it's just a different way of writing, especially within a notebook. So all we're going to do is do this little hashtag, and actually I think it's a pound sign, but I'm going to call it hashtag. We're going to do that. And we're going to say first notebook. And then if I run that, we have our first notebook, and we can make little comments and little notes like that that don't actually run any code. They just kind of organize things for us. And I'm going to do that in a lot of our future videos. So just wanted to show you how to do that. Now let's look right up here. A lot of these things are pretty important. One of the first things that's really important is actually saving this. So let's say we wanted to change the title to, I'm going to do AAA because I want it to be at the beginning so I can show you this. I'm going to do AAA new notebook, and I'm going to rename it. And then I'm going to save that. So if I go right back over here, you can see AAA new notebook. That green means that it's currently running. And when I say running, I mean right up here. And if we wanted to, we'd go ahead and shut that down, which means it wouldn't run the code anymore. And then we'd have to run up a new cluster. So let's go ahead and do that. I didn't plan on doing that, but let's do it. So we have no notebooks running. And right here, it says we have a dead kernel. So this was our Python 3 kernel. And now since I stopped it, it's no longer processing anything. So let's go ahead and say try restarting now. And it says kernel is ready. So it's back up and running and we're good to go. The next thing is this button right here. Now this is an insert cell below. So if I have a lot of code I know I'm going to be writing, I can click a lot of that. And I often do that because I just don't like having to do that all the time. So I make a bunch of cells just so I can use them. You can also delete cells. So say we have some code here, we'll say here, and we have code here. And then we have this empty cell right here. We can just get rid of that by doing this cut selected cells. We can also copy selected cells. So if I hit copy selected cells, then I can go right here and say paste selected cells. And as you can see, it pasted that exact same cell. You can also move this up and down. So I can actually take this one and say I wanted it in this location. I can take this cell and move it up, or I can move it down. And that's just an easy way to kind of organize it instead of having to like copy this and moving it right down here and pasting it. You can just take this cell and move it up, which is really nice. Now earlier when I ran this code right here, I hit Shift Enter. You can also run and it'll run the cell below. So you can hit run and it works properly. If you're running a script and it's taking forever and it's not working properly, at least you don't think it's working properly, you can stop that by doing this interrupt the kernel right here. And anything you're trying to do within this kernel, if it's just not working properly, it'll stop it. You can restart it, then you can try fixing your code. You can also hit this button if you want to restart your kernel, and this button if you want to restart the kernel and then rerun the entire notebook. As we talked about just a second ago, we have our code and our markdown code. We're not going to talk about either of these because we're not going to use that throughout the entire series. The next thing that I want to show you is right up here. If you open this file, we can create a new notebook. We can open an existing notebook. We can copy it, save it, rename it, all that good stuff. We can also edit it. So a lot of these things that we were talking about, you can cut the cells and copy the cells using these shortcuts if you would like to. We also go to view and you can toggle a lot of these things if you would like to, which just means it'll show it or not show it depending on what you want. So if we toggle this toolbar, it'll take away the toolbar for us. Or if we go back and we toggle the toolbar, we can bring it back. We can also insert a few different things like inserting a cell above or a cell below. So instead of saying this plus button, you can just say A or B, or adding above or below. We also have the cell in which we can run our cells or run all of them or all above or all below. And then we have our kernels right here, which we were talking about earlier, where we can interrupt it and restart those. There are widgets. We're not going to be looking at any widgets in this series, but if it's something you're interested in, you can definitely do that. And then we have help. So if you are looking for some help on any of these things, especially some of these references, which are really nice, you can use those and you can also edit your own keyboard shortcuts. And now that we walked through all of that, you now have Anaconda and Jupyter Notebooks installed on your computer. In future videos, this is where we're going to be writing all of our Python code. So be sure to check those out so we can learn Python together. Hello, everybody. Today, we're going to be learning about variables in Python. A variable is basically just a container for storing data values. So you'll take a value like a number or a string, and you can assign it to a variable, and then the variable will carry and contain whatever you put into it. So for example, let's go right over here. we're going to say x, and this is going to be our variable. We're going to say is equal to. Now we can assign the value to it. So let's say I want to put 22. X is now equal to 22. So we won't have to write out the number 22 in later scripts that we write. We can just say x, because x is equal to 22. It now contains that number. So now we can hit enter and say print. We'll do an open parentheses and we'll say x. Now I'm going to hit shift enter. And now it prints out that 22 because we are printing x, and x is equal to 22. This is our value and this is our variable. One really great thing about variables is that it assigns its own data type. It's going to automatically do this. So we didn't have to go and tell x that it's an integer. It just automatically knew that 22 is a number. So we can check that by saying type and then open parentheses and writing x. And we'll do shift enter again. And this says that x is an integer type. Now we only assigned an integer to x. Let's try assigning a string value or some text to a variable. So we'll say y is equal to, let's say mint chocolate chip. I'm feeling some ice cream today. So we'll say mint chocolate chip. Now, if we print that again, we'll do print open parentheses y and do shift enter. It'll print mint chocolate chip. And if we look at the type, we can see that the type is a string this time and not an integer. Now again, we did not tell it that x was an integer and y was a string. It just automatically knew this. Let's go over here really quickly. We're going to add several rows in here because we're about to write a lot of different variables and really learn in depth how to use variables. The next thing to know about variables is that you can overwrite previous variables. Right now we have mint chocolate chip, and that is assigned to the variable y. So if I go down here and I say print y, and I hit shift enter, it's going to print out mint chocolate chip. But if I go right above it, I say y is equal to, and let's say chocolate. If I print that out, it's now going to say chocolate. Whereas up here, I'm reassigning it to y. It's still going to say mint chocolate chip. So if I come right down here and I copy this, and I'm going to paste this right here, initially it is going to assign y to chocolate. But then right here, it will automatically overwrite y as mint chocolate chip. And when we hit shift enter, it's going to show mint chocolate chip. Variables are also case sensitive. So if I come up here and I say a capital Y, this is a lowercase y and this is a capital Y, it is going to print out the correct one instead of mint chocolate chip. And then if I go down here to the print and I type the capital Y, it will give us the mint chocolate chip. Up till now, we've only assigned one value to one variable, but we can actually assign multiple values to multiple variables. So let's do x, y, z is equal to, and now we can assign multiple values to all of those. So we can say chocolate, and then we'll do a comma, and then we can say vanilla, and then we'll do another comma, and we'll say Rocky Road. Now, this is going to assign chocolate to x, vanilla to y, and Rocky Road to z. So what we can do is we'll say print, and we'll go print, and we'll say x, y, and z. So it prints out chocolate, vanilla, and Rocky Road. And these are our three different values. We can also assign multiple variables to one value. And we can do this by saying x is equal to y is equal to z is equal to, and we can put whatever we would like. Let's do root beer float. Then we'll come back up here. We'll copy this. And let's print off our x, our y, and z. And they are all the exact same. Now, so far, we've really only looked at integers and strings, but you can assign things like lists, dictionaries, tuples, and sets all to variables as well. So let's go right down here. So let's create our very first list. I'm going to say ice underscore cream is equal to, and that is our variable right there. The ice underscore cream is our variable. So now we're going to do an open bracket like this, and we're going to come up here and copy all of these values, and we're going to stick it within our list. So now within ice cream, we have three string values, chocolate, vanilla, and Rocky Road, all within this list. So what we can do is we can say x, comma y, comma z is equal to ice underscore cream. So now these three values, chocolate, vanilla, and rocky road, will be assigned to these three variables, x, y, and z. And we can copy this print up here, and we'll hit Shift Enter. And now the x, y, and z all were assigned these values of chocolate, vanilla, and rocky road. Now, something that we just did, which is really important, or something that you really need to consider, is how you name your variables. So right here, we have ice cream. Now, this to me is exactly how I usually write my variables, but there are many different ways that you can write your variables. So let's take a look at that really quickly. And let's add just a few more because I have a feeling we're going to go a little bit longer than what we have. So there are a few best practices for naming variables. First, I'm going to show you kind of what a lot of people will do. I'll show you some good practices, and I'm going to show you some bad practices as well that you should avoid doing. The first thing that we're going to look at is something called camel case. And let's say we want to name it test variable case. Case. Now, if we have a test variable case, the camel case is going to look like this. We'll have lowercase test, and then we'll have uppercase variable, and uppercase case is equal to. This is what this variable is going to look like. And we can assign it vanilla swirl. And this is what your camel case will look like. It's going to be lowercase, and then all the rest of those compound words, or however you want to say that, these letters are going to be capitalized to kind of separate where the words end and begin. Let's go right down here. We're going to copy this. The next one is called Pascal case. So Pascal case is going to look just a little bit different. Instead of the lowercase at test, it's going to be a capital T in test. So test variable case. Again, this is a very similar way of writing it, very similar to camel case, but just a capital at the beginning. Now let's look at the last one, and this one is my personal favorite. This one is going to be the snake case. Now this one is quite a bit different in the fact that you don't use any capital letters and you separate everything using underscore. So we're going to write test underscore variable underscore case. Now, typically, let me have them all in there. Typically, these are the best practices. These are what you typically want to do. But probably the best one to use is this snake case right here. What a lot of people say is that it improves readability. If you take a look at either the camel case or the Pascal case, which you will see people do, it's not as easy to distinguish exactly what it says. And the name of a variable is important because you can gain information from it if people name them appropriately. So when I'm naming variables, I usually write it in snake case because I just find it a lot easier to read because each word is broken up by this underscore. So now let's look at some good variable names. These are all ones that you can use or could use. So let's do something like test var. So test var is completely appropriate. We can also do something like test underscore var. Underscore. We could do underscore test underscore var. You'll see that often as well. Well, people will start it with an underscore. You can do test var, capital T, capital T, capital V in test var. Or you could even do something like test var 2. Now, adding a number to your variable is not inherently a bad thing. Usually it's semi-frowned upon, but there are definitely some use cases where you can use it. But one thing that you cannot do is do something like putting the 2 at the front. If you put the 2 at the front, it no longer works. It won't run properly at all. So we're going to take that out. So we can't do that. So I'm going to use this as an example of what you should not do. You also can't use a dash. So something like test dash var2, that doesn't work either. And you also can't use something like a space or a comma, or really any kind of symbol like a period or a backslash or equal sign. None of those things will work within your variable. Now, another thing that you can do within your variable is use the plus sign. So let's assign this. We'll say x is equal to, and we'll do a string. We'll say ice cream is my favorite. And then we'll do a plus sign and we'll say period. Now, what this will do is it will literally add these two strings together. So let's do print and we'll do X. So now it says ice cream is my favorite. One thing that we cannot do in a variable is we cannot add a string and a number or an integer. So we can't do ice cream is my favorite 2. If we try to do that, it will give us this error right here. So in this error, it's saying you can only concatenate a string, not an integer, to a string. So only a string plus a string for this example. You can also do, and we'll say X is equal to, or we'll say Y. We'll say Y is equal to 3 plus 2, and it should output 5, because you can also do an integer and an integer. Now, so far, we've only been outputting one variable in the print statement, but you can actually add multiple variables within a print statement. So let's go right down here. We're going to say, let's give it some more right there. So we'll say X is equal to ice cream, and we'll say Y is equal to is, and then the last one, Z, is equal to my favorite. And we'll do a period at the end. Now we can go to the bottom and we can say print X plus Y plus Z. And when we enter that, and when we run that, we get ice cream is my favorite. Now we can actually add a space before is, a space before my, and when we hit Shift Enter, it says ice cream is my favorite. You can also do this exact same thing with numbers as well. So we'll say X is equal to 1, 2, and Y, Z is equal to 3. So this should equal 6. Now, one thing that we tried to do was assign to one variable a string plus an integer, and that did not work. But what you can do is you can take something like this and you can say ice cream, and we'll get rid of this one, and we'll get rid of the Z. Now, saying plus is actually not going to work. Let's try running this. So again, we can't concatenate these, but what we can do in the print statement is we can separate it by a comma. So when we add this comma, it should work properly. Let's hit enter, and it says ice cream 2. Again, this makes no sense, but you are able to combine a string and an integer separating by a comma. Now, this is the meat and potatoes of variables. There are some other things as well, but some of those things are a little bit more advanced and not something I wanted to cover in this tutorial. Although we may be looking at some of those things in future tutorials, but this is definitely the basics, what you really need to know about variables. Hello, everybody. Today, we're going to be talking about data types in Python. Data types are the classification of the data that you are storing. These classifications tell you what operations can be performed on your data. We're going to be looking at the main data types within Python, including numeric, sequence type, set, Boolean, and dictionary. So let's get started actually writing some of this out. And first, let's look at numeric. There are 3 different types of numeric data types. We have integers, float, and complex numbers. Let's take a look at integers. An integer is basically just a whole number, whether it's positive or negative. So an integer could be a 12, and we can check that by saying type. We'll do an open parentheses and a close parentheses. And if we say the type of 12, it's going to give us an integer. Or if we say a negative 12, that is also an integer. We can also perform basic calculations like minus 12 plus 100, and that'll tell us it is also an integer. So whether it's just a static value or you're performing an operation on it, it's still going to be that data type if those numbers are whole numbers, whether negative or positive. Now let's take this exact one and let's say 12, and we'll do plus 10.25. When we run this, it's no longer going to be a whole number. It'll now be a float. So let's check this. And now this is a float type because it is no longer a whole number. It's now a decimal number. And the last data type within the numeric data type is called complex. Let's copy this right down here. Now, personally, this is not one that I've used almost ever, but it is one just worth noting. So you can do 12 plus, and let's say 3j. And if we do this, it's going to give us a complex. The complex data type is used for imaginary numbers. For me, it's not often used, but if you do use it, j is used as that imaginary number. If you use something like C or any other number, it's going to give you an error. J is the only one that will work with it. Now let's take a look at Boolean values. So we'll say Boolean. The Boolean data type only has 2 built-in values, either true or false. So let's go right down here and say type true. And when we run this, it'll say bool, which stands for Boolean. We can do the exact same thing with false and that is also Boolean. And this can be used with something like a comparison operator. So let's say 1 is greater than 5, and let's check this. This is giving us a Boolean because it's telling us whether 1 is greater than 5. Let's bring that right down here. This will give us a false. So it's telling us that 1 is not greater than 5. And just as we got a false, we can say 1 is equal to 1, and this should give us a true. So now let's take a look at our sequence type data types, and that includes strings, lists, and tuples. Let's start off by looking at strings. In Python, strings are arrays of bytes representing Unicode characters. When you're using strings, you put them either in a single quote, a double quote, or a triple quote. I call them apostrophes. It's just what I was raised to call them, but most people who use Python call them quotes. So right here we have a single quote, and that works well. We can do a double quote, and that works also. And as you can see, they are the exact same output. And then we have a triple quote, just like this. And this is called a multi-line. So we can write on multiple lines here. So let's write a nice little poem. So we'll say, the ice cream vanquished my longing for sweets. Upon this diet, I look away. It no longer exists on this day. And then if we run that, it's gonna look a little bit weird. It's basically giving us the raw text, which is completely fine, but let's call this a multi-line. And we're gonna call this a variable multi-line. And we're gonna come down here and say print. And before I run this, I have to make sure that this is ran. So now let's print out our multi-line. And now we have our nice little poem right down here. Now, something to know about these single and double quotes is how they're actually used. So if we use a single quote and we say, I've always wanted to eat a gallon of ice cream, and then we do an apostrophe at the end, obviously something went wrong here. What went wrong is when you use a single quote and then within your text, within your sentence, you have another apostrophe, it's going to give you an error. So what we want to do is whenever we have a quote within it, we need to use a double quote. These double quotes will negate any single quotes that you have within your statement. They won't, however, negate another double quote. So you need to make sure you aren't using double quotes within your sentence. If you want to do something like that, you need to use the triple quotes like we did above. So we can do double, double, and then let's paste this within it. And anything you do within these triple quotes will be completely fine, as long as you don't do triple quotes within your triple quotes. We'll say this is wrong. So even though it's between these two triple quotes, it doesn't work exactly. Again, you just have to understand how that works. You have to use the proper apostrophes or quotes within your string. And just to check this, we can always say, here's our multi-line. We can always say type of multi-line, and that is still a string. One really important thing to know about strings is that they can be indexed. Indexing means that you can search within it, and that index starts at 0. So let's go ahead and create a variable, and we'll just say a is equal to, and let's do the all popular hello world. Let's run this. And now when we print this string, we can say a, and we're going to do a bracket. And now we can search throughout our string using the index. So all you have to do is do a colon. We can say 5. What this is going to do is going to say 0, position 0, all the way up to 5, which should give us the whole hello, I believe. Let's run this. And it's giving us the first 5 positions of this string. We can also get rid of the colon and just say something like 5. And then when we run this, it's actually going to give us position 5. So this is 0, 1, 2, 3, 4, and then 5 is the space. Let's do 6 so we can see the actual letter, and that is our W. We can also use a negative when we're indexing through our string. So we could say -3, and it'll give us the L because it's -1, 2, and 3. We can also specify a range if we don't want to use the default of 0. So before we did 0 to 5, and it started at 0 because that was our default, but we could also do 2 to 5. Let's run this, and now we go position 0, 1, and then we start at 2, L, L, O. Now we can also multiply strings, and we have this A hello world. So we can do A times 3, and if we run this, it'll give us hello world 3 times. And we can also do A plus A, and that is hello world, hello world. Now let's go down here and take a look at lists. Lists are really fantastic because they store multiple values. The string was stored as one value, multiple characters, but a list can store multiple separate values. So let's create our very first list. We'll say list really quickly, and then we'll put a bracket, and a bracket means this is going to be a list. There are other ones like a squiggly bracket and a parentheses. These denote that they are different types of data types. The bracket is what makes a list a list. So to keep it super simple, we'll say 1, 2, 3, and we'll run this. And now we have a list that has 3 separate values in it. The comma in our list denotes that they are separate values. And a list is indexed just like a string is indexed. So position 0 is this 1, position 1 is the 2, and position 2 is the 3. Now, when we made this list, we didn't have to use any quotes because these are numbers. But if we wanted to create a list and we wanted to add string values, we have to do it with our quotes. So we'll say quote cookie dough, and then we'll do a comma to separate the value. And then we'll say strawberry, and then we'll do one more, and this will just be chocolate. And when we run this, we have all 3 of these values stored in our list. Now, one of the best things about lists is you can have any data type within them. They don't just have to be numbers or strings. You can basically put anything you want in there. So let's create a new list, and let's say vanilla. And then we'll do 3, and then we'll add a list within a list, and we'll say scoops, comma, spoon, and then we'll get out of that list, and then we'll add another value of true for Boolean. And now we can hit Shift Enter, and we just created a list with several different data types within one list. Now let's take this one list right here with all of our different ice cream flavors. We'll say ice underscore cream is equal to this list. Now, one thing that's really great about lists is that they are changeable. That means we can change the data in here. We can also add and remove items from the list after we've already created it. So let's go and take ice cream, and we'll say ice cream dot append, and this is going to append it to the very end of the list. We'll do an open parentheses, and let's say salted caramel. Now, when we run this and we call it just like this, it's going to take this list, add salted caramel to the end, and we'll print it off. And as you can see, it was added to the list. And just like I said before, let me go down here. We can also change things from this list. So let's say ice cream, and then we need to look at the indexed position. So we're going to say 0, and that's going to be this cookie dough right here. We can say that is equal to, so we can now change that value. So let's call that butter pecan. And now when we call it, we can now see that the cookie dough was changed to butter pecan. Another thing that you saw just a little bit ago is something called a list within a list, basically a nested list. So we had scoops, spoon, true. Let's give this, and we'll say nested underscore list is equal to. Now, when we run this, we now have this nested list. So if we look at the index and we say 0, we'll get vanilla. If we say 2, we'll get scoops and spoons. Now, since we have a list within a list, we can also look at the index of that nested list. So let's now say 1, and that should give us just spoon. And you can go on and on and on with this. You can do lists within lists within lists, and all of them will have indexing that you can call. Now let's go down here and start taking a look at tuples. So a list and a tuple are actually quite similar. But the biggest difference between a list and a tuple is that a tuple is something called immutable. It means it cannot be modified or changed after it's created. Let's go right up here. We're going to say tuple. And let's write our very first tuple. So we'll say tuple underscore scoops is equal to, and then we'll do an open parentheses. Now these open parentheses you've seen if you do like a print statement, but that's different because that's executing a function. This is actually creating a tuple, which is going to store data for us. So we'll say 1, 2, 3, 2, and 1. Let's go ahead and create that tuple. And we can just check the data type really quickly. And it's a tuple. And just like we saw before, a tuple is also indexed. So if we go at the very first position, which is a 1, we will get the output of a 1. But we can't do something like append and then add a value like 3, if we do that, it's going to say tuple object has no attribute append. It's just because you cannot change or add anything to a tuple, just like we were talking about before. Typically, people will use tuples for when data is never going to change. An example for this might be something like a city name, a country, a location, something that won't change. They definitely have their use cases, but I don't think they're as popular as just using a list. So now let's scroll down and start taking a look at sets. But really quickly, let me add a few more cells for us. And let's say sets. Now a set is somewhat similar to a list and a tuple, but they are a little bit different in the fact that they don't have any duplicate elements. Another big difference is that the values within a set cannot be accessed using an index because it doesn't have an index because it's actually unordered. We can still loop through the items in a set with something like a for loop, but we can't access it using the bracket and then accessing its index point. So let's go ahead and create our very first set. So we're going to say daily underscore pints. Then we're going to say equal to, and to create a set, we're going to use these squiggly brackets. I don't know if there's an actual name for those, if I'm being honest. I call them squiggly brackets, and that's what we're going to go with. We're going to put in a 1, a 2, and a 3. So let's go ahead and run this. And let's look at the type. And as you can see, it is a set. Now, when we print this out, it's going to show us 1, a 2, and a 3. And those are all the values within our set. But if we copy this and we'll say daily pints log, this is going to be every single day. Maybe I had different values. Now, when we run this and we do the exact same thing, now when we print this, it's going to have just the unique values within that set. Now, a use case for set, and this is something that I've done in the past, is comparing two separate sets. Maybe you have a list or a tuple and you convert that into a set, and that will narrow it down to its unique values. And then you can compare the unique values of one set to the unique values in another set, and then we can see what's the same and what's different. So let's go down here and let's say wife's underscore daily, and we'll just copy this right here. We'll say is equal to, let's do our squiggly lines. Let's do 1, 2, let's do just random numbers. So now this is my daily log and this is my wife's daily log. And now we can compare these values. So let's go right down here. Let's say print. We'll do my daily logs. And then we'll do this bar right here. And this is going to show us the combined unique values. It's basically like putting them all in one set and then trimming it down to just the unique values. So we'll take wife's daily pints log. And when we run this, we actually need to run this first. When we run this, we should see all the unique values between these two sets. And so as you can see, 0, 1, 2, 3, 4, 5, 6, 7, 24, 31. So these are all the unique values between these two sets. We can also do another one. And instead of this bar, we're going to do this symbol right here, which I believe is called an ampersand. Don't quote me on that. But when we run this, it's going to show what matches. That means which ones show up in both sets. So the only ones that show up in both sets are 1, 2, 3, and 5. We can also do the opposite of that by doing a minus sign. And this is going to show us what doesn't match. And so we have 4, 6, and 31. Now, where is our 24 that was in our wife's daily pints log? It's in this one, but we're subtracting the values on this one. So let's reverse this and we'll say daily pints log, and let's run it. Now those are our other values. So we're taking the values of this and then we're subtracting all the ones that are the same and getting the remaining values. And then for our last one, we can get rid of this and we'll do this symbol right here. And this is going to show if a value is either in one or the other, but not in both. So let's run this. So these values are completely unique only to each of those sets. Now, the very last one that we're going to look at in this video is dictionaries. So let's go right down here. Let's add a few cells and let's say dictionaries. Now I saved dictionary for last because this one is probably the most different out of all the previous data types that we've looked at. Within a data type, we have something called a key value pair. That means when we use a dictionary, it's not like a list where you just have a value, comma, value, comma, value. We have a key that indicates what that value is attributed to. So let's write out a dictionary to see how this looks. we're going to say dictionary underscore cream. And just like a set, we use a squiggly line. But the thing that differentiates it is that in a dictionary, we'll have that key value pair, whereas in a set, each value is just separated by a comma. So let's write name, and this is our key. And then we do a colon, and this is then where we input our value. So we're going to say Alex Freeberg. And then we separate that key value pair by a comma, and now we can do another key value pair. So we'll say weekly intake and a colon, and we'll say 5 pints of ice cream, do a comma, and then we'll do favorite ice creams. And now what we're going to do is we're going to put in here a list. So within this dictionary, we can also add a list. We'll do MCC for mint chocolate chip, and then we'll add chocolate, another one of my favorites. So now we have our very first dictionary. Let's copy this and run it. And let's just look at the type. And as you can see, it says that this is a dictionary. Let's also print it out. Now, if we want to, we can take our dictionary cream and say dot values with an open parentheses. And when we execute this, we'll see all of the values within this dictionary. So here's our values of Alex Freeberg, 5, mint chocolate chip, and chocolate. We can also say keys. And when we run this, all of the keys, the name, weekly intake, and favorite ice creams. And we can also say items. So this key value pair is one item, and this key value pair is another item. Now, one difference between something like a list and a dictionary is how you call the index. But you can't call it by doing something like this, where you just do a bracket, and say 0. So this would, in theory, take this very first one, right? Our very first key value pair. That's going to give us an error. How you call a dictionary is actually by the key. So it doesn't technically have an index, but you can specify what you want to call and take it out. So we're going to say name, and this is going to call that key right here. And when we run this, we'll get the value, which is Alex Freeberg. One other thing that you can do is you can also update information in a dictionary, which we can't with some other data types. So for this, for the name, it was Alex Freeberg. Now let's say Christine Freeberg. And when we update that, I'm also going to print the dictionary, get rid of this. So it's going to update Christine Freeberg in that value of the name. So let's go ahead and run this. And now it changed the name from Alex Freeberg to Christine Freeberg. We can also update all of these values at one time. So let's copy this. And I'm going to put it right down here. I'm going to say dictionary.cream.update. Then we're going to put a bracket, or not a bracket, but a parentheses around these. So now what we're going to do is update this entire thing. Let me take this, say print this dictionary. Now we can update this to anything we want. So instead of here, I can say, I'll say weight. And because of all that ice cream, I now weigh 300 pounds. So let's run this. And as you can see, it did not delete our key value pair right here. Instead, it just added to it. When you're using the update, we can't actually delete. That's the delete statement, and I'll show you that in just a second. But all we did was added this new value. It also is going to check and see if you changed anything with your key value pair. So we can go in here and change this value, and we'll say 10. So now when we run this, the value of this key value pair was changed. But let's say we do want to delete it. We'll say DEL, that stands for delete, part of this dictionary cream. And now let's specify the key, which will also delete the value with it. But let's specify the key that we want to get rid of. And let's say weight. And then let's print that again. And as you can see, the weight was deleted from that dictionary. So hello, everybody. Today, we're going to be taking a look at comparison, logical, and membership operators in Python. Operators are used to perform operations on variables and values. For example, you're often going to want to compare two separate values to see if they are the same or if they're different within Python, and that's where the comparison operator comes in. Right here, you can see our operators. You can also see what they do. So this equal sign stands for equal. We have the does not equal, the greater than, less than, greater than or equal to, and less than or equal to. And honestly, I use these almost every single time I use Python, so these are very important to know and know how to use. So let's get rid of that really quickly and actually start writing it out and see how these comparison operators work in Python. The very first one that we're gonna look at is equal to. Now, you can't just say 10 is equal to 10. Let's try running that really quickly by clicking Shift Enter. It's going to say cannot assign to literal. That's because this is like assigning a variable. We're trying to say 10 is equal to 10, and then we can call that 10 later. But that's not how this actually works. What we're trying to do is to determine whether 10 is equal to 10. So we're going to say equal sign, and then if we run that by clicking Shift Enter again, it's going to say true. Now, if we put something else like 50 in there and we try to run this, it's going to say false. So really what you're going to get when you use these comparison operators is either a true or a false. If we take this right down here, we can also say does not equal, and we're going to use an exclamation point equal sign, and that says 10 is not equal to 50, and that should be true. You can also compare strings and variables. So let's go right down here, and we're going to say vanilla is not equal to chocolate. And when we run this, it'll say false. Now, if it was the same, just like when we did our numbers, it should say true. And we can also compare variables. So we'll say X is equal to vanilla and Y is equal to chocolate. And then when we come down here, we can say X is equal to Y, and it'll give us a false. And we say X is not equal to Y, and it'll give us a true. The next one that we're going to take a look at is the less than. So let's copy this one right up here. Let's scroll down. And let's say 10 is less than 50. Now this will come out as true. Now let's say we put a 10 in here. Before 10 was of course less than 50, but is 10 less than 10? No, that's false because they are the same. So if we want an output that is true, all we would have to add is an equal sign right here. And this would say 10 is less than or it is equal to 10. And now it's true. Of course, we can say the exact same thing by saying greater than. So 10 is equal or greater than 10. That'll be true because 10 is equal to 10. But we can also say 50 is greater or equal to 10 because 50 is obviously greater than 10. Now let's look at logical operators that are often combined with comparison operators. So our operators are and, or, and not. So if you have an and, that returns true if both statements are true. If it's or, only one of the statements has to be true. And the not basically reverses the result. So if it was going to return true, it would return false. I don't use this not one a lot, but I will show you how it works. So let's actually test that out. So before we were saying 10 is greater than 50. And of course, this returned false. So now let's add a parentheses around this 10 is greater than 50. And we're going to say and, we'll do an open parentheses, 50 is greater than 10. Now this statement right here is true. 50 is greater than 10. So we have a true statement and a false statement. But this and is going to look at both of them. And it's going to say they both need to be true in order to return a true. So let's try running this. And we still have a false. If we wanted to return true, we're going to have to change this to make it a true statement. So 70 is greater than 50 and 50 is greater than 10. When we run this, it should return true. Now let's look at the or. So let's copy this and we'll say 10 is greater than 50 or 50 is greater than 10. Now this is a false statement and this is a true statement. So if even one of them is a true statement, the output should be true. And again, we can do this even with strings. So we can do vanilla and chocolate. There we go. And vanilla is actually greater than chocolate because V is a higher number in the alphabetical order. So V is like 20 something, whereas chocolate is 3, right? So it actually looks at the spelling for this. So if we say or here, it will come out true. And if we say and here, it should also be true because V is greater than C and 50 is greater than 10. So this should also be true. Now let's copy this right here and we're going to say not. So what we had before is 50 is greater than 10, that returned true. But now all we're doing is putting not in front of it. So instead of returning true, it's going to return false. So now let's take a look at membership operators. And we use this to check if something, whether it's a value or a string or something like that, is within another value or string or sequence. Our operators are in and not in, so it's pretty simple. If it's in, it's going to return true if the sequence with a specified value is present in the object, just like we were talking about. And for not in, it's basically the exact same thing if it's not in that object. So let's start out by taking a look at a string. We're going to say ice underscore cream is equal to I love chocolate ice cream. And then we're going to say love in ice underscore cream, and that will return true. So all we're doing is searching if the word love or that string is in this larger string. We could also just do that by literally copying this and putting this where this is. So we can check, is this string part of this string? And it'll say true. We can also make a list. So we'll say scoops is equal to, and then we'll do a bracket and we'll say 1, 2, 3, 4, 5. And then we'll say 2 in scoops. So all we're doing is searching to see if 2 is within this list, and that should return true. Now, if we put a 6 here and we said not in, it will also return true because 6 is not in scoops, and that is true. And just like we did, we could also say wanted underscore scoops, and we'll say 8. So I wanted 8 scoops. So we can say wanted scoops in scoops, and this should return true because there's not an 8 within the scoops that we wanted. And if we said in, and we said we wanted 8, is that within our list that we created? And that's going to return a false. Hello, everybody. Today, we're going to be taking a look at the if statement within Python. Now, it's actually the if, elif, else statement, but that's a mouthful, so I'm just going to call it the if, else statement. Now, we have this flowchart, and I apologize for it being blurry, but this is the absolute best one that I could find. Right up top, we have our if condition. Now, if this if condition is true, we're going to run a body of code. But if that condition is false, we're going to go over here and go to the elif condition. The elif condition or statement is basically saying, if the first if statement doesn't work, let's try this if statement. If this elif statement is true, it goes to this body of code. If it's false, it'll come over here to the else. And the else is basically, if all of these things don't work, then run this body of code. Now you can have as many elif statements as you want, but you can only have one if statement and one else statement. So let's write out some code and see how this actually looks. Let's first start off by writing if. That is our if statement, and now we have to write our condition, which is about to be either met or not met. So we'll say if 25 is greater than 10, which is true, we'll say colon, and then we're going to hit enter. And it's going to automatically indent that line of code for us. And this is our body of code. So if 25 is greater than 10, our body of code will execute. So for us, we're just going to write print and we'll say it worked. Now, if we run this, it's going to check, is 25 greater than 10? If that is true, print this. So let's hit shift enter and it worked. Now let's take this exact code, we'll paste it right down here and we'll say is less than. And right now, this if statement is not true. So it's not actually going to work. As you can see, there's no output. There's nothing that happened really, but it did check to see if 25 was less than 10, but it just wasn't true. Now we can use our else statement. So we're going to come right down here and we're going to say else, and we'll do a colon, and we'll hit enter again, automatically indenting. And we're going to say print, and we're going to say it did not work, ... So what it's going to do is it's going to come up here and check, is 25 less than 10? No, it's not. So this body of code is not going to be executed. It's going to go right down to this else statement. Now this else statement is going to be printed. There's no condition on this. So the if statement has a condition, 25 is less than 10. This has no condition. So if this doesn't work, if this is false, it's going to come down here and it will run this body of code. Let's run this by clicking shift enter. And as you can see, our output is it did not work. Now let's go back up here and put greater than, because this is now true. It's going to say if 25 is greater than 10, print it worked, and then it's going to stop. It's not going to go to this else statement at all. So let's run this, and our output is it worked. So what if we have a lot of different conditions that we want to try? Let's come right down here. This is where the elif comes in. So really quickly, let's change this to a not true, a false statement. We're going to go down and say elif, and we're going to say if it is, and let's say 30, we'll say elif worked. So now it's going to check, is 25 less than 10? No, it's not. Let's look at the next condition. Is 25 less than 30? And if it is, we'll print elif worked. So let's try running this, and elif worked. Now we can do as many of these elif statements as we want. We can do, let's just try a few of them right here. So we'll say if 25 is less than 20 is less than 21, and let's do 40, and let's do 50. So we'll say elif, elif2, elif3, and elif4. Now, if you look at this, the first one that is actually going to work is this 25 to 40 right here. Once this one is checked and it comes out as true, none of the other elif or else statements will work. So let's try this one. It should be elif3, and this one ran properly. Now within our condition so far, we've only used a comparison operator. We can also use a logical operator like and or. So we can say if 25 is less than 10, which it's not, and let's say or actually, and we'll say or 1 is less than 3, which is true. If we run this, now it will actually work. So we can use several different types of operators within our if statement to see if a condition is true or not, or several conditions are true. There's also a way to write an if else statement in one line if you want to do that. So we can write print, we'll say it worked. And then we'll come over here and say if 10 is greater than 30. And then we'll write else print, and we'll say it did not work. Just like we had before, except now it's all occurring on one line. So let's just try this and see if it works. So it's saying print it worked if 10 is greater than 30, which it wasn't. So it went to the else statement, and then it printed out our body right here. Although we didn't have any indentation or multiple lines, it was all done in one line. Now there's one other thing that we haven't looked at yet, and I'm going to show it to you really quickly, and that's a nested if statement. So when we run this, it's going to say it worked. It works because it says 25 is less than 10 or 1 is less than 3. Since this is true, it's going to print out it worked. But we can also do a nested if statement. So we can do multiple if statements as well. So we're going to hit enter and we'll say if, and we'll do a true statement here. So we'll say if 10 is greater than 5. Let's do a colon, hit enter, and then we'll say print. And then we'll type a string saying this nested if statement, worked. Now let's try this out and see what we get. So it went through the first if statement. It said it was true and it prints out it worked. This is still the body of code. So it goes down to this next if statement and it says if 10 is greater than 5, we're going to print this out. And you could do this on and on and on. It can basically go on forever and you can create a really in-depth logic. And that actually happens a lot when you start writing more advanced code. Hello, everybody. Today we're going to be learning about for loops in Python. The for loop is used to iterate over a sequence, which could be a list, a tuple, an array, a string, or even a dictionary. Here's the list that we'll be working with throughout this video. And I have this little diagram right here, which kind of explains how a for loop works. The for loop is going to start by looking at the very first item in our sequence or our list, and that's going to be our one right here. It's going to ask, is this the last element in our list? And it is not, so it's going to go down to this body of the for loop. Now we can have 1,000 different things that can happen in the body of the for loop as we're about to look at in just a second. Then it's going to go up to the next element and ask, is this the last element reached? So it'll be no again, because we'll be going to the 2, and then the 3, and then the 4, and the 5. Once it reaches the 5, it'll go to the body of the for loop. And then when it asks if that's the last element, the answer would be yes, because it's iterated through all the items within the list, and then we would exit the loop and the for loop would be over. Now that may not have made perfect sense, but let's actually start writing out the syntax of a for loop so we can understand this better. To start our for loop, we're going to say for, and then we're going to give it a temporary variable for this for loop. So it's a variable as it iterates through these numbers, it's going to assign the variable to that number. So for this one, we're just going to say number because it's pretty appropriate because these are all numbers. And then we're going to say in integers. Now, right here, you can put just about anything. This could be the list, this could be a tuple, this could be a string even. But that is what we're going to iterate through. So we're saying for the variables, each of these numbers, within this list of integers, and then we're going to write a colon. This is the body of code that's going to actually be executed when we run through and iterate through our list. So for our first example, we're going to start off super simple, and all we're going to do is say print, open parentheses, and say number. As it iterates through the 1, 2, 3, 4, and 5, number becomes our variable that is going to be printed. So during that first loop, our 1 will be printed because that will be assigned right here. Then through the next iteration, the 2 will be assigned and it'll be put right here in each loop until the very end. So let's hit Shift Enter. And as you can see, it did exactly that. Now in this body, and I'll copy and paste this down here, in this body, we really can do just about anything we want. We don't even have to use this variable number right here. We can just print yep if we wanted to. And what it's going to do is for each iteration, all 5 of those, every time it loops through, it's going to print off yep. So let's hit Shift Enter. And it printed it off for us. So really, we weren't even using the numbers within the list. We were really just using it as almost a counter. Now let's copy this integers once again. Let's go right up here and let's go copy this for loop that we wrote. Now, we do not have to call this number. This can be anything you want, any variable name that you'd like to name it. We could call it jelly, and we can do jelly plus jelly. I think you're getting the picture, right? When it loops through that 1, it's doing 1 plus 1. When it loops through the 2, it's doing 2 plus 2. That is basically how a for loop works. Now for a dictionary, it's going to handle it a little bit differently. So let's create a dictionary really quickly. So we'll say ice cream dictionary is equal to, we're going to do a squiggly brackets. So we're going to say name, and we're going to say colon. We need to assign our value for that item. So we're going to say Alex Freeberg. We'll do our next one separated by a comma, and we'll say weekly intake. And I'll say 5 scoops per week. The next one we will do is favorite ice creams. And for this one, we're going to do something a little bit different. For this, we're going to have a list within this dictionary. So we'll say within our list of my favorite ice creams, we'll say mint chocolate chip, and I'll just do MCC for that. And we'll separate that out by a comma, and we'll say chocolate. So now we have this dictionary, ice cream dict, and within it, we have my name, my weekly intake, and my favorite ice creams with a list in there as well. Let's hit Shift Enter. And now we're going to start writing our for loop. Now the for loop is going to look very similar, but to call a dictionary, it's just a little bit different. So we're going to say for the cream in ice underscore cream underscore dictionary dot values, and then we're going to do parentheses and then a colon. Now we're going to print the cream. So in order to indicate what we actually want to pull, we have to specify within the dictionary what we want. Are we pulling the item? Are we pulling the value? We need to specify this. So that's why we have this dot values right here. So let's run this and see what we get. So as you can see, we are pulling in the values right here. That's why we're pulling in Alex Freeberg, 5, and mint chocolate chip / chocolate. Now we are able to call both of those, both the key and the value. So let's go right down here, and we can do both the key and the value. So we can pull 2 things at one time. And we're going to do this by saying dot items. So we could also do dot key if we just wanted to do a key, but we want to do items, so we're going to do both of them. So we're going to go right down here and say for key and value in ice cream dictionary dot items print, and let's write key, and then we'll do a comma, and then let's give it a little arrow or something like that, something like this. And then we'll do a comma and we'll say value. And let's print this off and see what we get. So it's looping through, and for each key and value, it's saying here is the key. So that's the name. Then we have weekly intake. Then we have favorite ice creams. It's giving us a little arrow, and then we're also printing off the value. So we have name, Alex Freeberg, weekly intake 5, favorite ice creams, mint chocolate chip, and chocolate. So now let's talk about nested for loops. We've looked at for loops. We understand how they work and why they do what they do, but what about a nested for loop, a for loop within a for loop? For this example, let's create 2 separate lists. Let's create flavors, and let's make that a list by making it a bracket. And we'll do vanilla, the classic, chocolate, and then cookie dough. All great flavors. So that's our first list. And then we're going to say toppings. And we'll do a bracket for that as well. And we'll say hot fudge. And then we'll do Oreos, and then we'll do marshmallows. Is that how you spell marshmallows? I think it's an E. That looks wrong. I might be spelling it wrong, but that's okay. So let's save this by clicking Shift Enter. And now we have our flavors and our toppings. So now let's write our first for loop. So we're going to say for one, as in our number one for loop. We're going to say in flavors, and we'll do a colon. We'll click Enter. Now we can write our second for loop. So we're going to say for two in toppings, and then we'll do a colon and Enter. And then we're going to say print, and we'll do an open parentheses, and then we're going to say one. So we're printing the one in flavors, and then we're going to say one, comma, I'm going to say topped with, comma, two. So what this is essentially going to do is we're going to say for one, we're going to take the very first one in flavors, and then we're going to loop through all of two as well. So we're going to loop through hot fudge, Oreos, and marshmallows. And once we print that off, then we will loop all the way back to flavors and look at the next iteration or the next sequence within the first for loop. So let's run this really quickly and see what we get. So as you can see, it goes vanilla, vanilla, vanilla. And vanilla is topped with the hot fudge, the Oreos, and the marshmallows. And then we start iterating through our second one in our first for loop. So there's that hierarchy. So we're iterating completely through this one before we actually go to the very first for loop and start iterating through that one again. Now that is essentially how a nested for loop works. These nested for loops can get very complicated. In fact, for loops in general can get very complicated the more you add to it and the more you're wanting to do with it. But that is basically how a for loop and a nested for loop works. Hello everybody. Today we're going to be taking a look at while loops in Python. The while loop in Python is used to iterate over a block of code as long as the test condition is true. Now, the difference between a for loop and a while loop is that a for loop is going to iterate over the entire sequence regardless of a condition. But the while loop is only going to iterate over that sequence as long as a specific condition is met. Once that condition is not met, the code is going to stop and it's not going to iterate through the rest of the sequence. So if we take a look at this flowchart right here, we're going to enter this while loop and we have a test condition right here. The first time that this test condition comes back false, it's going to exit the while loop. So let's start actually writing out the code and see how this while loop works. So let's create a variable. We're just going to say number is equal to 1. And then we'll say while. And now we need to write our condition that needs to be met in order for our block of code beneath this to run. So we're going to say while number is less than 5. And then we'll do colon, enter. And now this is our block of code. We're going to say print. And then we'll say number. Now what we need to do is basically create a counter. We're going to say number equals number plus 1. If you've never done something like this, it's kind of like a counter. Most people start it at 0. In fact, let's start it at 0. And then each time it runs through this while loop, it's going to add 1 to this number up here. And then it's going to become a 1, a 2, a 3 each time it iterates through this while loop. Now, once this number is no longer less than 5, it'll break out of the while loop and it will no longer run. So let's run this really quick by hitting Shift Enter. So it starts at 0 and it's going to say while the number is less than 5, print number. So the first time that it runs through, it is 0. And so it prints 0 and then it adds 1 to number. And then it continues that while loop right here. And it keeps looping through this portion. It never goes back up here to this line of code. This is just our variable that we start with. And then once this condition is no longer met, once it is false, then it's going to break out of that code. Now that we basically know how a while loop works, let's look at something called a break statement. So let's copy this right down here. And what we're going to say is if number is equal to 3, we're going to break. Now with the break statement, we can basically stop the loop even if the while condition is true. So while this number is less than 5, it's going to continue to loop through, but now we have this break statement. So it's going to say if the number equals 3, we're going to break out of this while loop. But if this is false, we're going to continue adding to that number just like normal. So let's execute this. So as you can see, it only went to 3 instead of 4 like before, because each time it was running through this while loop, it was checking if the number was equal to 3. And once it got to 3, this became true, and then we broke out of this while loop. The next thing that I want to look at, and we'll copy this right down here, is an else statement, much like an if statement, but we can use the else statement with a while loop, which runs the block of code, and when that condition is no longer true, then it activates the else statement. So we'll go right down here, and we'll say else, and we'll do a colon, and enter, and then we'll say print, and we'll say no longer less than 5. Now, because this if statement is still in there, it will break. So let's say 6, and then we'll run this. And so it's going to iterate through this block of code. And once this statement is no longer true, once we break out of it, we're going to go to our else statement. Now, as long as this statement is true, it's going to continue to iterate through. But once this condition is not met, then it will go to our else statement and we'll run that line of code. Now, the else statement is only going to trigger if the while loop no longer is true. If we have something like this if statement that causes it to break out of the while loop, the else statement will no longer work. So let's say if the number is 3 and we run this, the else statement is no longer going to trigger, so this body of code will not be run. Now, the next thing that I want to look at is the continue statement. If the continue statement is triggered, it basically rejects all remaining statements in the current iteration of the loop, and then we'll go to the next iteration. Now, to demonstrate this, I'm going to change this break into a continue. So before, when we had the break, if the number was equal to 3, it would stop all the code completely. But when we change this to continue, which we'll do right now, what it's going to do is it's no longer going to run through any of the subsequent code in this block of code. It's just going to go straight up to the beginning and restart our while loop. So what's going to happen when we run this is it's going to come to 3, it's going to become 3, and it's going to continue back into the while loop, but it's never going to have that number change to be added to 1 to continue with the while loop. This will basically create an infinite loop. Let's try this really quickly. And as you can see, it's going to stay 3 forever. Eventually this would time out, but I'm just going to stop the code really quick. So if we just change up the order of which we're doing things, we're going to say there, and we're going to put this down here. So what it's going to do now, instead of printing the number immediately and then adding the number later, we're going to add the number right away. And then we're going to say, if it is 3, we're going to continue and it's going to print the number. So let's try executing this and see what happens. So as you can see, we no longer have the 3 in our output. What it did was when we got to the number 3, it continued and didn't execute this right here, which prints off that number. Hello, everybody. Today we're going to be taking a look at functions in Python. A function is a block of code which is only run when you call it. So right here, we're defining our function. And then this is our body of code that when we actually call it is going to be ran. So right here, we have our function call, and all we're doing is putting the function with the parentheses. That is basically us calling that function. And then we have our output. Throughout this video, I'm going to show you how to write a function as well as pass arguments to that function. And then a few other things like arbitrary arguments, keyword arguments, and arbitrary keyword arguments. All of these things are really important to know when you are using functions. So let's get started by writing our very first function together. We're going to start off by saying def. That is the keyword for defining a function. Then we can actually name our function. And for this one, we're just going to do first underscore function, and then we do an open parentheses. And then we'll put a colon, we'll hit enter, and it'll automatically indent for us. And this is where our body of code is going to go. Now within our body of code, we can write just about anything. And in this video, I'm not going to get super advanced. We're just going to walk through the basics to make sure that you understand how to use functions. So for right now, all we're going to say is print. We'll do an open parentheses, we'll do an apostrophe, and we'll say, we did it. And now we're going to hit shift enter. And this is not going to do anything, at least you won't see any output from this. If we want to see the output, or we actually want to run that function, and some functions don't have outputs, but if we want to run that function, what we have to do is just copy this. I'm going to put it right down here. And now we're going to actually call our function. So let's go ahead and click shift enter. And now we've successfully called our first function. This function is about as simple as it could possibly be, but now let's take it up a notch and start looking at arguments. So let's go right down here, and we're going to say define number underscore squared. And we'll do a parentheses and our colon as well. Now, really quickly, when you're naming your function, it's kind of like naming a variable. You can use something like X or Y, but I tend to like to be a little bit more descriptive. But now let's take a look at passing an argument into a function. The argument is going to be passed right here in the parentheses. So for us, I'm just going to call it a number. And then we're going to hit enter, and now we'll write our body of code. And all we're going to do for this is type print and open parentheses, and we'll say number, and we'll do 2 stars, at least that's what I call it, a star, and a 2. And what this is going to do is it's going to take the number that we pass into our function. It's going to put it right here in our body of code. And then for what we're doing, it's going to put it to the power of 2. And so when the user or you run this and call this function, This number is something that you can specify. It's an argument that you can input that will then be run in this body of code. So let's copy this right here, and then we'll put it right down here into this next cell, and we'll say 5. And so this 5 is going to be passed through into this function and be called right here for this print statement. Let's run it, and it should come out as, I believe, 25. That is my fault. I forgot to actually run this block of code. So I'm going to hit Shift Enter. So now we've defined our function up here, and now we can actually call it. So now we'll hit Shift Enter, and we got our output of 25. Now in this function, we only called one argument, but you can basically call as many arguments as you want. You just have to separate them by commas. So let's copy this, and we'll put it right down here. Now we'll say number squared underscore custom, and then we'll do number, and then we'll do power. So now we can specify our number as well as the power that we want to raise it to. So instead of having 2, which is what you call hard-coded, we can now customize that, and we'll have power. And now when we call this function, we can specify the number and the power, and both of those will go into this body of code and be run, and we can customize those numbers. So let's copy this, and we'll say 5 to the power of 3. And let's make sure I ran this. So let's do Shift Enter. And now we will call our function, and let's hit Shift Enter. And we got 5 to the power of 3, which is 125. And just one last thing to mention is if you have 2 arguments within your function and you are calling it right here, you have to pass in 2 arguments. You can't just have one. So if we have a 5 right here, it's going to error out. We have to specify both arguments for it to work. Now let's take a look at arbitrary arguments. Now, arbitrary arguments are really interesting because if you don't know how many arguments you want to pass through, if you don't know if it's a 1, a 2, or a 3, you can specify that later when you're calling the argument, so you don't have to do it up front and know that information ahead of time. So let's define our function. So we're going to say define, and then we're going to say number underscore args, and we'll do an open parentheses and a colon. Now within our argument right here, typically we would just specify here's what our argument will be. It will be number, or it will be a word, right? But what we're going to do is something called an arbitrary argument. So it's unknown. So we're going to put star, and then we'll say args. Now you will see something exactly like this. Typically, if you're looking at tutorials, they'll have star args in there, or if you're looking at just a generic piece of code, this is what it will look like. But for us, we're going to actually put number. So again, we have the star, and then we have our arbitrary argument right here. And then we'll hit enter, and we're going to say print, open parentheses, and this is where it's going to get a little bit different. So we're going to say number, and then we're going to do an open bracket, and let's say 0, and then we'll do that times, and then we'll say number again with a bracket of 1. So in a little bit, once we run this and then we call this number args function right here, we're going to need to specify the number 0 and the number 1 that's going to be called. So let's go ahead and run this. And then we are going to call it. And let's say 5, 6, 1, 2, 8. So right up here, we did not know how many arguments we were going to pass through. It could be 5, it could be 1,000. We could also call in a tuple, and that's what this is right here. We're calling in a tuple. So what it's going to do now is when it calls this number, it's going to call the very first within that tuple, which will be that 5. And then it'll also call in this number, which will be the first position, which is the 6. So let's hit Shift Enter, and it's going to multiply these numbers together. So 5 times 6 is equal to 30. Now, like I just said, this is a tuple. So we don't actually have to write out these numbers like we just did. We can pass through a tuple when we are actually calling this function. Let's do that right up here. Let's just create, let's call it args underscore tuple, and we'll do open parentheses, and we'll do the same numbers. Let's just copy it to make it easier. And now we've created this tuple right here, which we can then pass in. And this is a lot more handy, a lot more specific, and this is most likely how someone would do something like this. But let's now create this. And now we can copy args tuple and pass it through. Now, really quickly, this is going to fail, and I'm doing that on purpose, but I want to show you what you need to do in order to pass through this tuple. So right now it's going to say tuple index is out of range. All you have to do in order to use this is you have to specify a star before it, just like you did when you were creating your argument up here. We have to put a star in front of our tuple that we just passed through. And now let's try running this. And now it works properly. Now, the last two things that we're going to look at are keyword arguments and arbitrary keyword arguments. There are more things that you can learn and do within functions, but again, I'm just trying to teach you the basics to make sure that you understand how they work. So let's go right up here. And a keyword argument is kind of similar to this right here. And let's actually copy this and put it right down here. Now, a keyword argument is very similar in that you're going to specify your arguments right here. But what we did up here, let me bring this down. When we actually called the function, what we did was we just put in a 5 and a 3. And when we did that, it automatically assigned number to 5 and power to 3. And that's totally fine, and you can do that. But if you want a little bit more control, you can use a keyword argument. So right here, we could say power is equal to 5 and number is equal to 3. So I just switched it around, right? Number was assigned to 5 and power was assigned to 3, but I just switched it to show you how this might work. So let's run both of these. And now it's 3 to the power of 5, which is 243. So that essentially is a keyword argument. Again, it just gives you a little bit more control. You don't have to put them in specific positions, like if you're just calling multiple arguments. Now let's come right down here. We're going to create basically another custom function. So for this one, we're going to write define number underscore arg. And then we'll do an open parentheses, a colon, and enter. And what this one is this one is a keyword argument or an arbitrary keyword argument. Now to specify an arbitrary argument, all we did was a star, and then we input number. But if we're doing a keyword argument, we actually have to have 2 stars right here. So let's start taking a look. And again, if you're doing arbitrary, it means we don't really know how many keyword arguments we want to pass into our function. So we're just going to put star star number, and then later within our body of code, and when we're calling it, we'll be able to specify it. And just like the arbitrary argument before, the arbitrary keyword argument means we really just don't know how many keyword arguments we're going to need to pass into our function. So to demonstrate this, let's write print, do an open parentheses, and we'll say need to do an apostrophe. My number is, and we'll do just like that, little space, and we'll say plus. And this is kind of where it gets a little interesting or a little bit more tricky. So what we're going to say is number. So this is us calling our number. And then we're going to do a bracket. And then I'm actually going to go to calling the function. It's a little bit backward or a little bit different than what you might think. But when we're calling it, what I'm going to do is I'm going to say integer is equal to, and let's just do some random number. Now, when we're calling that keyword within our body of code, what we're going to do is we're going to actually type out integer, just like this. And this looks a little bit different, but what this allows us to do is we can put as many keyword arguments in here as we want later, and I'll show you in just a second. But for us, we're just creating this key and this value when we are calling it within the function. So now when we create this and we run this, oh, whoops, I forgot. This has to be a string. So let's run this again. Now what we'll say, my number is 2309. Then we're going to add, we'll say plus, and this isn't going to look great, but we'll say my other number, because this will all be in the same line. That's okay. My other number, and then we'll say number, and we can specify again what we want in there. So now we can go down here to where we're calling it. We'll just put a comma. And we'll say integer 2 is equal to, and we'll do a random number. And then we'll put integer 2 right here. And then we'll add plus right here so we don't error out. We'll create this, we'll run this. And as you can see, both numbers were passed through. Again, the syntax is terrible, but now you can see that you have this arbitrary keyword argument right here. And all we have to do is put number, and we can pass through as many of these arbitrary keyword arguments as we want, as long as we just specify it within our function when we're calling it. Hello, everybody. Today, we're going to be talking about converting data types in Python. In this video, I'm going to show you how to convert several different data types, including strings, numbers, sets, tuples, and even dictionaries. So let's start off by creating a variable. We'll say num_int is equal to 7. And we can check that data type by saying type, and then inserting our variable num_int. And that will tell us that our data type for this variable is an integer. Let's go ahead and create another one. We're going to say num underscore string is equal to, and for this one, we'll also do a 7, but let's check the type, and we'll do an open parentheses, and we'll say the type of num string, and that one is a string. Now let's say we wanted to add those. We'll say num underscore sum, so the sum of num underscore int plus num underscore string. Now, when we're adding these two values, it is not going to work. It's going to give us an error, and it's going to say unsupported operand for int and string. So it cannot add both an integer and a string. What we need to do in order to add these two numbers is to convert that string into an integer. So let's go right up here. Let's add another cell, and let's say num underscore string underscore converted is equal to, and we want to convert it into an integer. So all we have to do to convert it into an integer is type int, and then we're going to say num underscore string. And that is as easy as it's going to get. All we have to do is say integer with our num string inside of it, and then it's going to convert it. And we can even check it right after by saying type num string converted, and let's run this. And now we can see that it was converted into an integer. So now let's add that num string converted right here. Let's copy and replace that string with the string converted. And let's actually print out that num underscore sum, and it worked properly. Now we did not specify what type of value this num sum was going to be, but because it was two integers in here, it's going to automatically apply that data type of integer to that num sum. Let's go right down here. And now let's look at how we can convert lists, sets, and tuples. So now let's say we have a list underscore type, and that's equal to 1, 2, 3. And we can check it again by saying type, and that is a list. Let's say we want to convert it to a tuple. It's fairly easy. All we're going to do is write tuple, say list underscore type. And that list underscore type is now going to be a tuple. And we can check that by saying type and wrapping it around this tuple. And it shows us that it is converting that list into a tuple. Now we can also convert a list into a set, but it may change the actual values within it. And let's check that out really quickly. So let's say we have this list, and let's add a few more values to this, just like that. Now let's say we want to convert it to a set. So we're going to run this, and we'll say set of list underscore type. And let's try running this and see what the output is. So this is something that you really need to be aware of when you are converting data types, because set does not act the same as a list. A set is basically going to take the unique values in the list and convert it to a set, and it fundamentally changes the data that was in that original list. And just to check the data type, we can say type. I'm just doing this for all of them. And as you can see, that is now a set. Now let's go down here and take a look at dictionaries. Now let's say we have a dictionary called dictionary underscore type. And we'll do a squiggly bracket, and we'll say name, and we'll do a colon, and we'll say Alex. Then we'll do age, and a colon, and we'll say 28. And then we'll do hair, colon, and so really quickly, let's take that dictionary type and just confirm that it is a dictionary, and it is. And now what we're going to do is take a look at all of the items within that dictionary. So we're going to do dictionary type dot items, open parentheses, and this is going to show us all the items within it. Now we can also take this and look at something like the values. And when we run that, these are our values. So within our dictionary, we have items, and that's what this is right here. This is one item. And then within that, we have our values, which are right here. So Alex, 28, and NA. And then we have something called a key. And this is the key. The name, age, and hair are all keys. And we can look at that by saying dot keys. So let's say we want to take all of the keys and put that into a list. What we're going to do is we're going to take this right here. We're going to say list. We'll do an open parentheses. We'll type that in right there. So it says a list, and we're converting these keys into a list. And let's run that. And now this is a list. And let's just check the type as well, just to confirm. And as you can see, it was converted properly into a list. And we can do the exact same thing with values. And the values can also be converted into a list. Now we can also convert longer strings that aren't just numbers like we did above in our very first example. So let's do long underscore string, and we'll say, I like to party. Now we're going to take this string and we're going to say list long string. So we're going to convert this string into a list. And let's see what happens. So it took every single character in that string and put it into a list. And we could also do a set as well. That one's a lot shorter because it's only looking at unique values. So that is how you convert data types in Python. Hello, everybody. Today we're going to be working on building a BMI calculator in Python. Now, before we get started, I want to show you this BMI calculator that I found online. And it shows you the basic calculation that they use, and that's the one we're going to use in this video. And they also have this calculator right down here and some ranges that we can use for our calculator as well. So for reference, I weigh about 170. I'm about 5'9". Let's calculate this. So I'm about a 25.1 BMI, which falls into the overweight category. That's unfortunate. But we can see exactly how this works and how ours should work when we actually build it. So we're going to kind of reference this throughout the video. So let's go right over here to our BMI calculator. We need to calculate weight and height and then run this calculation right here. So let's go ahead and copy this. And we're going to put it right down here. And so now we have our calculation. So what we need is we need input from a user. And there is an input function within Python that we're going to be using. So let's actually give me a few more cells. So the first thing that we need to calculate is their weight. Let's type out weight right here. We'll say weight is equal to, and this is where we'll use our input function. So we'll say input. And when we actually run this, it's just going to give us this blank square where a user can input something. We'll say Alex. So this is our output, is what the actual user input. And it does save it to this variable. So if we say print weight, it will still print out Alex. Now this is where we want the user to, just like we did before, where they'll input their weight. So we want to kind of give them a prompt for this. We'll put a string in here. So I'll do a double quote. And then I'll say, enter your weight in, and we're using pounds. Let's say pounds, colon, space. So now when we do this, it'll say, enter your weight in pounds. I'll say 170. And then when we run this, it does store that. Now let's do print. I should have saved it. Weight again. Oops. Now it's only storing the value of 170. It's not actually storing this string right here. So that's really important for when we do our calculations later. I'm gonna save this right down here because I'm sure I'm gonna use that later. So we have that, it's working. Now we need to also do our height. So let's copy this and we'll put it right here. And we'll do height and enter your height in inches. So now for this one, if we hit enter, that's actually running. Let's stop it really quick and interrupt it. Let's try running this. So it's going to say enter your weight in pounds. That's the first input, say 170. And then when I hit enter, it's going to prompt me for that second input. And so in inches, 5'9" is 69 inches. And then I can hit enter again. And now we have both of our inputs. Now we need this calculation right down here. And just like that. So now we have weight in pounds times 703 divided by height in inches by height in inches. So we actually have weight, and it's already written in there, but I'm just going to do it like this. We'll do weight times 703. So that's pounds. There are weight in pounds times 703 divided by, now we have our height in inches times the height in inches. So this is our calculation right here. So let's do this exact same thing. Let's run this. And this times, of course, is not going to work. Whoops. We need to do our star for both of these. All right, now this is our calculation. So let's run this. So we have 170, and that's pounds, and inches was 69. We hit enter. And it says cannot multiply the sequence of non-integer type of string. That's because these are being stored in strings. So if right down here, and we'll do type of height, and we run that, this is actually a string. So we want to change that because we don't need that anymore. Get rid of that. So we don't want it to be a string. We need those to be integers or floats or really anything besides a string. It just needs to be numerical. So integer or float really. So let's do integer and then we'll wrap that input in it. And we'll do the same thing for this one. Now we have an integer for our weight, an integer for our height. So now when we're running this calculation, it should work properly. Let's run this again. Our pounds are 70. Our height is 69 inches. And it's not giving us our output because we're not printing anything. Okay, so I just need to do print BMI. So let's try this again. 170, 69, and there is our BMI, 25.1. So it worked the exact same as this one. So they input, well, we input our height, we inputted our weight, we inputted our height, and then it calculated our BMI. The next thing that we need to do is we need to kind of give the user some context. Is that good? Is their BMI within a good range, a bad range? We don't know. So let's go ahead and I'm going to see if I can copy this. I don't know if this will work or not. Let's go ahead and copy this right down here. Perfect. So what we now need to do is we need to say, okay, if the user has given us this input, we want to give them or tell them if they are a normal weight, overweight, obese, severely obese, anything like that. And we have these ranges, so that should help us out quite a bit. So let's just write our if statement and then we'll include it up here. But let's go down here and we'll say if, and then we'll do BMI. And let's just say BMI is greater than 0. So if it's greater than 0, if they had any input where the BMI was not 0, which should be every time if they do it properly and they don't, put a string in there or something or type out 40, which maybe we should make a prompt for that if that happens. Then we can say if, we'll do BMI, and now we need to give that first range. So this range right here. So if it's under 18.5, so we need to do a less than. So if it's less than 18.5, and it just says under, it doesn't say under or equal to, so I'll keep it at 18.5. So if it's under 18.5, then let's give kind of the output. We'll say print, and the output or basically the prompt is underweight. So we'll just say you are underweight, and just like that. And then we're going to pass several elif statements through here. Well, let's just say else. So I guess this would be like if they don't input something properly or something messes up, maybe we could write something like print. Oops. I'm thinking all this through. We can write print, enter valid inputs or something like this, or we can always change that. But let's run this. Okay, so I'm not in that range. Let's make the next one. So then I can be within a certain range. Oops. And we should need one more at a minimum. So we'll say elif and elif. These next two are this 24.9. So it's going to check this one first. So if it's 18.5 or below 18.5, it's automatically going to print this one. So this next one, we don't have to do like a range or anything. We can just say if it's between 25 and 29.9. So this one actually should be less than or equal to. This one is normal. Oh, whoops. 24.9. So this one is 24.9. This one is going to say you are normal weight. So let's run this now. Let's see. BMI was 25.1. Oh, guys, I'm just messing up here. I apologize. All right. This is the one that I was part of. So now it's going to be part of the overweight crowd. Now let's run this. And now our prompt is you are overweight. Because remember, the BMI was saved right here as 25.1. Down here, if we run through this, it's saying, no, you're not in, oops. Get rid of that. No, you're not in under 18.5. You're not under 24.9. If you're under 29.9, you are overweight. So that did work properly. So that's really good. And I don't think I want this to be our output for the person because we're going to add this up here. It's just going to give us the BMI. And then the output is going to say you are overweight. Let's make it a little bit more customized. I'm going to say name is equal to input. And then we'll say enter your name. So it'll be enter your name. We'll do Alex, 70, 69. There's our BMI. Now it's going to run through this logic, or it will run through this logic in just a second when we actually finish this. So then we have 34.9. And let's do one more. Oops. And then this one's going to be for 39.9. So this one was overweight. This one is obese, severely obese. So we'll say severely, is that how you spell it? Severely obese. And then anything that's over that, 40 and over. So if it's not this one, anything else should be morbidly obese. So actually this else statement right here should say you are severely obese. This is going to say morbidly obese. Now I added that name up here because I wanted to add that down below actually. So we're going to say name plus, and then we'll do like comma, you are underweight. So it'll be a little bit more personalized. I think it'll be a nice touch. I really do. We'll do it like this, and we'll say you. And let's go back and do that to all of them. And let me see how quickly I can do this. Oops. Oh, whoops, what did I do? Get rid of that. Name plus you, like that. Jeez, you guys are seeing me mess up a ton. Name plus you, and then name plus you. So now let's run this. And now it's a little more personalized. It says, Alex, you are overweight. So this is all really good. Now, this is an if statement. What we had done before, I think, is actually what we should put right down here. So we'll say else. And then if that doesn't work, we'll say, what do we say? Enter valid input. We'll just put that. And let me see if I can test this out. I don't know if this will error out or if this will even work. Let me just see if I can mess with it and see if I can get it to work. Actually, let's copy this. We're going to copy this whole thing. We're going to include it right here. And now we have basically our entire calculator. So let's run this. Enter your name. We'll say Alex. Enter your pounds, 170. Enter your inches, 69. And then it's going to say 25.1. Alex, you are overweight. And that's perfect. We could even go as far as adding like some feedback. We could say you are overweight, and then it would be a period. And we could say you need to exercise more, stop sitting and writing so many Python tutorials. So now if we run this, we'll do Alex, 170, 69. It says, Alex, you are overweight. You need to exercise more and stop sitting and writing so many Python tutorials, period. And that's it. This is the entire project. You can go a ton farther. You can include much more complex logic. You could even build out a UI to create your own, app just like this, where it has this input and this UI. You can build that out in Jupyter Notebooks with Python, but that's not really what this tutorial is for. This is just to kind of help you think through some of the logic of creating something like this. So hello, everybody. In this lesson, we're going to be taking a look at Beautiful Soup and requests. Now, these packages in Python are really useful. These are the two main ones that I used when I was first starting out with web scraping. it can get a lot of what you want done in order to get that information out. Now, of course, there are other packages that you can use that may be a little bit more advanced, but again, this is just the beginner series. In a future series, we'll look at other packages as well that have some more advanced functionality. So what we're going to be doing is we're going to import these packages, and then we're going to get all of the HTML from our website and make sure that it's in a usable state. And then in the next lesson, we're going to kind of query around in the HTML, kind of pick and choose exactly what we want. We'll look at things like tags, variable strings, classes, attributes, and more. So let's get started by importing our packages. What we're going to say is from BS4, this is the module that we're taking it from. We're going to say import, and then we'll do beautiful soup. Then we're going to come down and we're going to say import requests. Now let's go ahead and run this. I'm gonna hit Shift Enter, and it works well for me. Now, if this does not work for you, you may potentially need to actually install BS4. So you may have to go to your terminal window and say pip install BS4. I'll just let you Google how to do that if you need to do that, because it's pretty easy. But if you're using Jupyter Notebooks through Anaconda, like how we set it up at the beginning of this Python series, then you should be totally fine. It should be there for you. The next thing that we need to do is specify where we're taking this HTML from. So what we need to actually do is come right over here to our web page, and we need to get the URL. So we're going to go here, we're going to copy this URL, and I'm just going to put it right here for a second. And what we're going to do is we're going to be using this URL quite a bit. So we just want to assign it to a variable. So we'll just say URL is equal to, and then we'll put it right in here. Now we can get rid of that. So now this is our URL going forward. This is where we're going to be pulling data from. Let's go ahead and run this. Now we're going to use requests, and what we're going to do is we're going to say requests.get, and then we're going to put in URL. Now this get function is going to use the request library. It's going to send a get request to that URL, and it's going to return a response object. Let's go ahead and run this. As you can see here, I got a response of 200. If you got something like a 204 or a 400 or 401 or 404, all of these things are potentially bad. Something like a 204 would mean there was no content in the actual web page. 400 means a bad request. So it was invalid, the server couldn't process it, and you don't get any response. If you got a 404, that might be one that you're familiar with. That's an error that means the server cannot be found. The next thing that we're going to do is take the HTML. Now, if you remember, if we come right back here and we inspect this, we have all of this HTML right here. Now on this web page specifically, right now, it's completely static. It's not a bunch of moving stuff or anything like that. But usually when you're looking at HTML, if you're looking at something like Amazon, and those web pages can update, but when you actually pull that into Python, you're basically getting a snapshot of the HTML at that time. So what we're going to do is bring in all of this HTML, which is our snapshot of our website, and then we can take a look at it. So we're going to come right down here, and now we're going to say beautiful soup. So now we'll use the beautiful soup package or library. So when you say beautiful soup, then we're going to do an open parentheses. We're going to do two things. There's two parameters that we need to put in here. First, we need to put in this get request. We actually need to name this, and we'll call this page. We'll say page is equal to, and let's run this. And now we're going to put that page in here. And what we're going to say is .text. So the page is what's sending that request. And then the .text is what's retrieving the actual raw HTML that we're going to be using. Then we're going to put a comma here. And what we need to specify is how we're going to parse this information. Now, this is an HTML. So what we're going to do is HTML, just like this. This is a standard. This is already built into this library, so we don't need to go any further, but it's basically going to parse the information in an HTML format. Now let's go ahead and run this. Let's see what we get. And as you can see, we have a lot of information. And as we scroll down, I'll try to point out some things that we've already looked at in previous lessons. Something like this TH tag. That should be very similar. That's the title. Then we have these TD tags. And then of course, if we scroll down even further, we'll have things like a TR tag. So these are all things that we looked at in that first lesson when learning about HTML. Now, again, we want to assign this to a variable. So we're going to say soup. That's going to say equal to this information right here. Now, I'm not going to go into all the history behind Beautiful Soup, but what I will say is the guy who created this Beautiful Soup library, what he said was that it takes this really messy HTML or XML, which you can also use it for, and it makes it into this kind of beautiful soup. So I just thought that was kind of funny, but that's why we're calling it soup right here. And we're going to go ahead and run this, and we'll come right down here and we'll say print soup. And let's run it. And now we have everything in here. So we have our HTML, our head, we have some href and some links in here. And let's scroll down a little bit more. And then we have our body right there. And of course, we have a bunch of information in here. Now, in the next lesson, what we're going to be doing is learning how to kind of query all of this to take specific information out and basically understand a lot of what's going on in this HTML to make sure we can actually get what we need. Now, if this looks really kind of messy to you and it just doesn't make a lot of sense, there is one more thing that I'm going to show you, and we'll come right down here. So we'll say soup.prettify. And if you've ever used a different type of programming languages, Prettify is very common in a lot of them, where it'll just make it a little bit more easy to visualize and see. You'll notice that it kind of has this hierarchy built in, whereas if we scroll up, there's no hierarchy built in. It's all just down this left-hand side. So if you kind of want to view it and just kind of visually see the differences, this does help a lot. But it doesn't actually help a lot when you're, querying it or using, find and find all, which is what we're going to look at in the next lesson. Now, the first thing that we need to learn is HTML. HTML stands for Hypertext Markup Language, and it's used to describe all of the elements on a web page. Now, when we actually go to a website and start pulling data and information, we need to know HTML so we can specify exactly what we want to take off of that website. So that's where HTML comes in, and we're going to look at the basics, understanding just the basic structure of HTML. Then we'll go look at a real website, and you'll kind of see that it's a little bit more difficult than what we just have right here. But this is the basic building blocks to get to what the HTML actually looks like on a website. Now, this is basically what HTML looks like. We have these angled brackets with things like HTML, head, title, body, and then you'll notice that at the end, we'll have a body, and then we'll have a body at the bottom. This /body denotes that this is the end of the body section in HTML. So everything inside of this is within this body. And so there is this hierarchy within HTML. We have HTML and HTML at the bottom, which encapsulates all the HTML on the website. Then we have things like head, body, and body. Now, within these sections, we usually have things like classes, tags, attributes, text, and all these other things that we'll get to in different lessons. But one of the easiest ones to notice and look at are tags, things like a p tag or a title tag. Now, within these tags, because this is a super simple example, we have these strings here, my first web page, and this is what's called a variable string, and this is actual text that we could take out of this web page. Now that you understand the super basics of HTML, let's actually go to our website, and I'm going to have a link down below, but it's going to be this one right here. This is basically just a website that you can, practice web scraping on. It's called scrapethissite.com. And what we're going to do is look at the HTML behind this web page, and you can do this on any website that you go on. So we're going to right click. We're going to go down to inspect. Now, right off the bat, this looks a lot more complicated and a lot more complex than the very simple illustration that we were looking at. But let's kind of roll this up just a little bit. You'll notice we have HTML and HTML at the bottom. We have a head, and there is the end of the head, and then a body and the end of the body. So in a super simple sense, it is similar, but just the information that's within it is a lot more difficult. Now, if we look at this title right here, this is our title tag. If we click this little arrow, this is our drop down. You'll notice that here we have this string, hockey teams, forms, searching, and pagination. Now, let's say we didn't want to click on that and go find it. There's something that's super helpful within this inspection page that you can click on right here. It says select an element in the page to inspect it. So we're going to click on that. And as we go through our page, and let's click on this title, it's going to take us to exactly where this is in our HTML. This is extremely helpful, extremely useful. For example, let's say the data I want is down here. I want to take in the Boston Bruins. I can click on it, and it's going to take me to where that is exactly in the HTML. This is where we can start writing our web scraping script to specify, okay, I'm looking for a TR tag. I'm looking for a TD tag. I'm looking for the class called team. This is all information and things that we can use to specify exactly what we want to pull out of our web page. Now, there are other things that we didn't really look at as well in just our simple illustration. Let's come right over here. There's things like hrefs. Now, these are hyperlinks. So if we went and then clicked on this, this is just regular text, but inside of it is this hyperlink, where if we clicked on it, it would take us to another website. And typically that's denoted by this href right here. Then you'll typically see things like a p tag, which usually stands for a paragraph. Now, the last thing that I want to show you while we're here, and we're going to learn a lot more in the next several lessons, but if we come right down here, there is this actual entire table here. And let's try to find this table. And I'm having trouble selecting the entire thing, but let's select this team name. And if we look at this team name, you can see that this is encapsulating the table. So this table tag. Now, these are super helpful because it takes in the entire table. Now, if we wrap this up and we look just at this, it says class table, and then we have the end of this table tag. Now, when we open it, it's going to have all of this information. So as you can see, as I'm highlighting over it, we have these TH tags, then we have these TD tags, and even these TR tags, which is the individual data. And this is something that we'll look at when we're actually scraping all of the data from this table in a future lesson. So this is how we can use HTML, how we can inspect the web page and see exactly what's going on kind of under the hood. And then in future lessons, we'll see how we can use this HTML to specify exactly what data we want to pull out. Hello everybody. In this lesson, we're going to be taking a look at find and find all. Really, we're going to be looking at a ton of different things in this lesson. This is where we really start digging in, seeing how we can extract specific information from our web page. But in order to do that, let's set everything up where we actually bring in the HTML like we did in the last lesson. And we're just going to write all this out one more time just for practice, if nothing else. And then we'll get into actually getting that information from the HTML. So we're going to start by saying from BS4 import beautiful soup. There we go. And import requests. We'll go ahead and run this. Then we're going to come up here, grab our HTML or our URL. So we'll say URL is equal to, and we'll have that right here. Now we need to say page is equal to, and then we'll do requests.get. And then we'll put in our URL right here. And we're going to come over here and run this. And lastly, we need to say soup. So we'll say soup is equal to beautiful soup. There we go. And then within our parentheses, we need to specify the page.text because we need that. And our parser, which is HTML. And there we go. And let's go ahead and run this. Let's print it out, make sure it's working. And there we go. So we have our soup right here. All this should look really similar to our last lesson. And so now we've brought in our HTML from our page. So we have a lot of information in here. Now, really quickly, let's come over and let's inspect our web page. Now in here, we have a ton of information, right? We have a bunch of different tags and classes and all these other things, but how do we actually use these? Well, that's where the find and find all is going to come into play, and they're pretty similar, and you'll see that in just a little bit. But let's say we want to take one of these tags, and let's come down. Let's say we just want to take this div tag. Now, there's going to be a lot of different div tags in our HTML, but let's just come right here. Let's go down, and let's say we're going to call soup. We're going to say soup. That's all of our information. We're going to say dot find. Now, within our parentheses, we can specify a lot of different things, but we're going to keep it really simple right now. We're just going to say div. Let's go ahead and run this. What this is going to bring up is the very first div tag in our HTML, and that's going to be this information right here. Now, let's copy this, and we're going to do the exact same thing, except we're going to say find underscore all. Now let's run this. Now we're going to have a ton more information. Really all find and find all do is that they find the information. Now find is only going to find the first response in our HTML at least. That's the div class container. Let's go back up to the top. That's our div class container, but find all is going to find all of them. So it'll put it in this list for you. So it's going to have this first one and it goes down to this /div, which should be right here. And then we have a comma, which separates our next div tag. So that is how we can use it. Now, what if we want to specify one of these div tags? We pulled in a ton of them, but we want to just look for one of them. Well, this is something where the class comes in handy because right now we have class is equal to container, class is equal to colmd-12. I don't know what these are off the top of my head, but usually they'll be somewhat unique And we can use these to help us specify what we're looking for. For example, just kind of glancing at this, we can also use this A tag if we wanted to look at this. So we could say, oh, we're looking for these hrefs. So we have an href here, and in this right down here, we have this href as well, which again, if you remember from a previous lesson, that stands for a hyperlink. Now, something like the class or the href or these IDs, these are all attributes. So we can specify or kind of filter down based off of these. Now let's try it. So what we can do is we can do class first, and this is kind of the default within something like find all, is you can even do class underscore. We can come right back up. We have this div, and then here's our class. So again, we have to have the div and the class. If we took this A tag, this is an A tag, which would go right here with the class of something like navlink or something like navlink again down here. We need to specify that more. But we have our div, so we'll say col md12 right here. And let's go ahead and run this. And now it's going to pull in just that information. Now we're still getting a list because we have multiple of these. So this div class col md-12 doesn't just happen once. If we scroll down, we'll see it multiple times, something like right here. Or actually, let me see right here. So here's this comma, then here's our next one. So we have two of these div tags with a class of col-md-12. And in each of these, we have different information. This looks like a paragraph with this p tag right here. And let's scroll back up. So I also think we should try out doing something like this p tag. Typically, these p tags stand for paragraphs or they have text information in them. Let's try to p tag really quickly and let's just see what we get. And let's run this. And it looks like we get multiple p tags. Now, if we come back here, you can see that there's this information and it's this information that we're pulling in. And I'm just noticing that from right here. And then we have this information right here. And it looks like there's one more, which is this href, which looks like this open source. So data via, and then that hyperlink or that link right there. So we have three different p tags. Now, just to verify and make sure that that's correct, what we could do is come over here. We're going to click on this paragraph. And it's going to take us to that p tag where the class is equal to lead. Let's come over here and look at this paragraph. Now we have another p tag right over here where the class is equal to glyphicon/education. I have no idea what that means. And then we'll go to our last one, which is right here, where the p tag is equal to, we have a tag, href, class, and a bunch of other information. So let's say we just wanted to pull in this paragraph right here. Let's go here and see how we can specify this information. So it looks like p, where the class is equal to lead, that looks like it's going to be unique to just that one. So if we come down here, we're going to say comma, and it was class. So you can do class underscore is equal to, and then we're going to say lead. Let's try running this. And we're just pulling in that information. Now, let's say we actually want to pull in this paragraph. We actually want this text right here. And this is a very real use case. Let's say I'm trying to pull in some information or a paragraph of text. Well, let's copy this. And what we're going to then do is say .text. And let's run this. Now we're going to get an error right here. And this is a very common error because we're trying to use find all. Unfortunately, find all does not have a text attribute. We actually need to change this to find. Typically, when I'm working with these find and find alls, I'm using find all most of the time until I want to start extracting text. Then when I specify it, I'll change this back to find just like this. Now let's try this. And now we're getting in parentheses this information. Now, this is all wonky. It needs to definitely be cleaned up a little bit. But if we go back up, it's no longer in a list. And we no longer have things like these p tags in here or this class attribute. So we're really just trying to pull out this information. Now, again, this does not look perfect. We could even try to do something like .strip. Look like there's some white space. That cleans it up a little bit. This definitely looks a little better. And we could definitely go in here and clean this up more. But just for an example, this is how we can then extract that information. Now let's look at one more example. This is some information, and this is what we're going to do kind of our little mini project in the next lesson on. Let's say we wanted to take all this information. Well, what if we wanted to pull in something like the team name? Well, that's going to be in right here in this TR tag. And each of these TR tags have TH tags underneath them. So if we scroll down, you'll notice that each row is this TR tag. So let's go ahead and search for, let's do TH. Let's just search for that first. So let's come right back up here. Let's use this find all. And we'll get rid of this text for right now. And let's just say we want to look for the TR. Is that what we said we were looking for? No, TH. So let's say we're looking for TH. Let's go ahead and run this. So we're going to have underneath this TH, we have team name, year, wins, losses. And notice these are all the titles. So these titles are the only ones with these TH tags. If we go down, you'll notice that the data is actually TD tags. So now let's go back and look for TD. We'll say D, and this is going to be a lot longer. We have a lot of information, but these are all the rows of data. Let's see if we can just get one piece of this data. We're going to get back. We want just this team name. That's all we're trying to pull in for now. And then we'll try to get this row. And then in the next lesson, we're going to try to get all of this information, make it look really nice, and then we'll put it into a pandas data frame. So let's just get this team name right now. Let's go ahead. We're going to say TH. Let's run this. And we have this TH. And now that we know we're getting this information in, we can do find. Let's run this. So there's our team name. I'm just going to say dot text. And again, we can do dot strip just like that. And bam, we have our team name. So you can kind of start getting the idea of how we're pulling this information out. We're really just specifying exactly what we're seeing in this HTML. And what's really, really helpful, and it's something that I do all the time, is I'm inspecting it. I'm just kind of searching like, what do I want? What piece of information do I want? Then I go ahead and click on it. And then I'm looking, where is this sitting in the hierarchy? It's within the body. It's within this table with the class of table. Then it's down here where this TR tag and then this TD tag. So I'm looking kind of at the hierarchy and I'm specifying exactly what I'm looking for. So that is what we're going to look at in today's lesson. That's how we can use find and find all. We were able to look at classes and tags and attributes and variable strings, which is this right here, getting that text, and variable strings. And we will look at find and find all and how it's pulling that information in and how we can specify exactly what we're looking for. Hello, everybody. In this lesson, we are going to be scraping data from a real website and putting it into a pandas data frame and maybe even exporting it to CSV if we're feeling a bit spicy. Now, in the last several lessons, we've been looking at this page right here. And I even promised that we were going to be pulling this data. But as I was building out the project, I honestly thought it was a little bit too easy, since in the last lesson, we kind of already pulled out some information from this table, and I want to kind of throw you guys off. So we're going to be pulling from a different table. We're going to be going on to Wikipedia and looking at the list of the largest companies in the United States by revenue. And we're going to be pulling all of this information. So if you thought this was going to be easy and a little mini project, it's now a full project, because why not? So let's get started. What we're going to do is we're going to import Beautiful Soup and requests. We're going to get this information and we're going to see how we can do this. And it's going to get a little bit more complicated and a little bit more tricky. We're going to have to, format things properly to get it into our pandas data frame to make it looking good and making it more usable. So let's go ahead and get rid of this easy table. We don't want that one. And we're going to come in here and we're just going to start off. This should look really familiar by now. We're going to say from BS4 import Beautiful Soup. I don't know if you've noticed, but I've messed up spelling Beautiful Soup in every single video. I've noticed. Let's run this. And now we need to go ahead and get our URL. So let's come up here. Let's get our URL. Say URL is equal to, and we'll just keep it all in the same thing really quickly, because we know this by heart by now, right? We'll say request.get and then URL to make sure that we're getting that information. It'd give us a response object. Hopefully it'll be 200. That'll mean a good response. And then we'll say soup is equal to, and then we'll say beautiful soup, and we'll do our page.text. Now we're pulling in the information from this URL. And then we use our parser, which will be, HTML. And let's go ahead and run this. Looks like everything went well. Let's print our soup. Now this is completely new to you. It's completely new to me. I don't know what I'm doing, but it looks like we're pulling in the information. Am I right? So we got a lot of things going for us. The stuff was imported properly. We got our URL. We got our soup, which is not beautiful in my opinion, but let's keep on rolling. Let's come right down here. Now what we need to do is we need to specify what data we're looking for. So let's come and let's inspect this web page. Now, the only information that we're going to want is right in here. We're going to want these titles or these headers. Whoops. So we're going to want rank, name, industry, etc. And then we are for sure going to want all of this information. Let's just scroll down, see if there's anything tricky in here. All right, that looks pretty good. And then there is another table. So there's not just one table in here. There are two tables in this page. So that might change things for us, but let's come right back and let's inspect our page by using this little button right here. And let's specify in, let's see if I can highlight just this page. Oh, it's not gonna, oh, let's do that right there. So now we have this wiki table sorter. Now I'm gonna actually come right here. I'm gonna copy and I'm just gonna say, copy the outer HTML. I'm just gonna paste it in here real quick. And that's a ton of information. I didn't think it was gonna copy all of it. And we're just gonna delete that. I just wanted to keep that class because I wanted to then come right down here at the bottom and just see what this table looks like. I don't know if it's part of it or if it's its own table. I can't tell. Let's look at this rank and let's come up. So it says it's under this table and it looks like it's its own table, but it says wiki table sortable jQuery table sorter. Wikipedia sortable jQuery table sorter. So it looks like there are two tables with the same class, which shouldn't be a problem if we're using find to get our text, because we should be taking the first one, which will be this table. And this is the table we want. And if we wanted this one, we could just use find all. And since it's a list, we could use indexing to pull this table, right? But I think we're going to be okay with just pulling in this one. So let's go ahead and let's do our find. So we'll do soup.find. And we could find all, or we could just do find table. Let's just try this and see what we get. And if it pulls in the right one that we're looking for, that'd be great. Now this does not look correct at all. I don't know what table it's pulling in. Oh, maybe it's this right here. This might be a table. Yeah, it is. So we have this box more citations. So actually we are going to have to do exactly like what I was talking about. Let's pull this and we could do comma class right here and let's do both. You know what? This is a learning opportunity. Let's do both. So let me go back up to the top because I need these. And what we're going to do, let's come right down here. I want to add in another thing. Actually, I'll just push this one up. There we go. So we're going to say find underscore all. Let's run this. So now we have multiple. And again, we got that weird one first, but if we scroll down, here's our comma. And then here's our wiki table sortable. And then we have rank, name, industry, all the ones that we were hoping to see. And I guarantee you, if we scroll all the way to the bottom, we're going to see potentially Wells Fargo, Goldman Sachs. I'm pretty sure those are, let's see. Yeah, here we go. Like Ford Motor, Wells Fargo, Goldman Sachs. That's this table right here. So now we're looking at the third table. But again, this is a list. So we can use indexing on this. And we'll just choose not position 0, because that's this one right here, which we did not like. Well, now we'll take position 1. Let's run this. Let's go back up to the top. And this is our table right here. Rank, name, industry. This is the information that we were actually wanting. And just to confirm, rank, name, industry, etc. So this is the information we're wanting. And we're able to specify that with our find all. And this is the information we want. So we now want to make this the only information that we're looking at. So I'm just going to copy this. We didn't need to use our class for this one. You probably could have, but we could. So let's actually put this right down here. This will be our table. We'll say equal to, but then I'll come right here and I'm going to say soup.find. And this is just for demonstration purposes. We'll do table, comma, class underscore is equal to, and then we'll look at this right here. Whoops, do this. And let's see if we get the correct output. And let's run this. And it looks like we're getting a none type object. If I remember, it looks like the actual class is this right here. So let's run this instead. And I got to get rid of the index. There we go. Okay, so we were able to pull it in just using the find. So the find table class, and it says wiki table sortable. At least that's the HTML that we're pulling in right here. Let me go back because I don't know if that's what I was seeing earlier. Let's just get this rank. Let's go back up. Oh, where's the rank? Go rank. There we go. So here's our rank, and let's go up to the table, and there's our class. Yeah, and that's just, to me, that's a little bit odd. So it says wiki table sortable jQuery dash table sorter right here. But in our actual Python script that we're running, it was only pulling in the wiki table sortable. So it wasn't pulling in the jQuery dash table sorter. Why? I'm not 100% sure, but all things that we're working through and we were able to figure out. So we're going to make this our table. We're going to say tables equal to soup.findAll. And let's run this. And if we print out our table, we have this table. Now this is our only data that we are looking at. Now the first thing that I want to get is I want to get these titles or these headers right here. That's what we're going to get first. So let's go in here. We can just look in this information. You can see that these are with these TH tags, and we can pull out those TH tags really easily. Let's come right down here. We're just going to say TH, and we can get rid of this. And let's run this. Now these are our only TH tags because everything else is a TR tag for these rows of data. So these TH tags are pretty unique, which makes it really easy, which is really great because then we can just do world underscore titles is equal to. So now we have these titles, but they're not perfect. But what we're going to do is we're going to loop through it. So I'm going to say world underscore titles, and I'll kind of walk through what I'm talking about. This is in a list, and each one is within these TH tags. So TH, and then there's our string that we're trying to get. So we can easily take this list and use list comprehension, and we can do that right down here. So I'm going to keep this where we can see it. We'll do world underscore table underscore titles. That's equal to, now we'll do our list comprehension. It should be super easy. We'll just say for title in world underscore titles. And then what do we want? We want title dot text. That's it. Because we're just taking the text from each of these. We're just looping through and we're getting rank. Then we're looping through, getting name, looping through, getting industry. That's it. So let's go and print our world table titles and see if it worked. And it did. This looks like it needs to be cleaned up just a little bit. So let's go ahead and do that while we're here before we actually put it into the pandas data frame. Oops, I just wanted this actually. So what we're going to do is try to get rid of those \ns. If we do .strip, that may actually not work. Yeah, because this is a list. What we need to do is we can actually do it .text.strip right here. Let's try to do it in there. There we go. So now we have this, and now this world tables is good to go. Now I'm actually noticing one thing that may be odd. Yeah, so we have rank name industry, it goes to headquarters, but then in here we're getting rank name industry and then the profits, which is from this table right here, which we don't want. Let's scroll back up. Now let's kind of backtrack this and see where this happened. We did find all table. We're looking at the first one, right? And then we're doing headquarters. So we're doing print table. Okay. I think I found the issue here. And let's backtrack again. We're working through this together. We're gonna make mistakes. The table is what we actually wanted to do. We just did soup.findAllTH, which is gonna pull in that secondary table. Geez, we were not thinking here. So now we need to do find all on the table, not the soup, because now we were looking at all of them. Oh, what a rookie mistake. Okay, let's go back. Now let's look at this. Now it's just down to headquarters. Okay, let's go ahead and run this. Let's run this. Now we just have headquarters. Now let's run this. Now we are sitting pretty. Okay, excuse my mistakes. Hey, listen, if it happens to me, it happens to you. I promise you. This is a project. This is a little project we're creating here. So we're gonna run into issues, and that's okay. We're figuring it out as we go. Now, what I want to do before we start pulling in all the data is I want to put this into our pandas data frame. We'll have the headers there for us to go, so we won't have to get that later, and it just makes it easier in general. Trust me. So we're going to import pandas as PD. Let's go ahead and run this. And now we're going to create our data frame. So we'll say PD dot. Now we have these world table titles. So what we're going to do is PD dot data frame. And then in here for our columns, we'll say that's equal to the world table titles. And let's just go ahead and say that's our data frame and call our data frame right here. Let's run it. There we go. So we were able to pull out and extract those headers and those titles of these columns. We're able to put it into our data frame. So we're set up and we're ready to go. We're rocking and rolling. The next thing we need, let's go back up. Next thing we need is to start pulling in this data right here. So we have to see how we can pull this data in. Now, if you remember that we had those TH tags, those were our titles. As you can see, I'm highlighting over it. But down here, now we have these TD tags, and those are all encapsulated within a TR tag. So these TR represent the rows, right? Then the D represents the data within those rows. So R for rows, D for data. So let's see how we can use that in order to get the information that we want. So let's go back up here. Just going to take this because, again, we're only pulling from table, not soup, not soup. What were we thinking? And let's go ahead and let's look at TR. Let's run this. Now, when we're doing this TR, these do come in with the headers. So we're going to have to, later on, we're going to have to get rid of these. We don't want to pull those in and have that as part of our data. But if we scroll down, there's our Walmart. We have the location. These are all with these TD tags. And then, of course, it's separated by a comma. Then we have our TD2. So above, we had our TD1. So row 1, row 2, row 3, all the way down. Now, we will easily be able to use this, right? Because this is our column data. And we can even call it that. Column underscore data is equal to, well, we'll run that. And what we're going to do is we're going to loop through that because it was all in a list. So we're going to loop through that information, but instead of looking at the TR tag, we're going to look at the TD tag. So let's come right down here. We'll say for the row in column row, and we'll do a colon. Now we need to loop through this. We'll do something like row.find underscore all. And then what are we looking for? We're not looking for the TR, we're looking for the TD. And just for now, let's print this off, see what this looks like. Apparently I didn't run this. Column data, that's why. And let's run this. And what we actually need to do is something almost exactly like this. And I'm going to put it right below it. Instead of printing this off, because again, this is all in a list, we're using find all, so we're printing off another list, which isn't actually super helpful. For each of all these data that we're pulling in, what we can do is we can call this the row underscore data, and then we'll put the row data in here. So we'll say for, and we'll say in row data. So we'll just say for the data in row data, and then we'll take the data, we'll exchange that. And now instead of world table titles, we can change this into individual row data, right? And now let's print off the individual row data. So it's the exact same process that we were doing up here. And that's how we cleaned it up and got this. And we may not need to strip, but let's just run this and see what we get. There we go. In strip, I'm sure was helpful. Let's actually get rid of this. Yeah, strip was helpful. It's the exact same thing that happened on the last one. So let's keep that actually. Let's run this. And now let's just kind of glance at this information. Let's look through it. This looks exactly like the information that's in the table. Let's just confirm with this first one. 572,754, 2.4, 2300, 572,754, 2.4, 2300. So this looks exactly correct. Now we have to figure out a way to get this into our table. Because again, these are all individual lists. It's not like we're just, putting all of this in at one time. We can't just take the entire table and plop it into the data frame. We need a way to kind of put this in one at a time. Now, if you're just here for web scraping and you haven't taken like my Panda series, that's totally fine. That's not what we're here for anyways. But what we can do, we'll have our individual row data and we're going to put it in kind of one at a time. Now, the reason we have to do that is because when we had it like this, and let's go back, when we had it like this, it's printing out all of it. But what it's really doing, and let's get rid of it. What it's really doing is it's kind of doing it like this. It's printing it off one at a time, and it's only going to save that current row of data, this last one. It's only going to save that as it's looping through. So what we actually want to do is every time it loops through, we append this information onto the data frame. So as it goes through, and eventually it's going to end up with this one, but as it goes through, let's run this. As it goes through, it puts this one in. And then the next time it loops through, it puts this one in. And the next time it loops through, et cetera, all the way down. So let's see how we can do this. So we have our data frame right here. Let's get rid of this. Let's bring our data frame in. Now, again, like I just mentioned, if you don't know pandas and you haven't learned that, go take my series on that. It's really good. And we do something very similar to this in that series. So I'm not going to kind of walk through the entire logic, but there is something called LOC, which stands for location when you're looking at the index on a data frame. And we're going to use that to our advantage. So we're going to say the length of the data frame. So we're looking at how many rows are in this data frame. And then we're going to say that's our length. Then we're going to take that length and use it when we're actually putting in this new information. Pretty cool. So we're going to say df.loc and then a bracket, and we're putting in that length. So we're checking the length of our data frame each time it's looping through. And then we're going to put the information in the next position. That's exactly what we're doing. Let's go ahead and put in the individual row data. So let's just recap. We're looping through this TR. This is our column data. So these TR, that's our row of data. Then as we're looping through it, we're doing find all and looking for TD tags. That's our individual data. So that's our row data. Then we're taking that data, each piece of data, and we're getting out the text and we're stripping it to kind of clean it. And now it's in a list for each individual row. Then we're looking at our current data frame, which has nothing in it right now. We're looking at the length of it, and we're appending each row of this information into the next position. So let's go ahead and run this. It's working, it's thinking, and it looks like we got an issue. Cannot set a row with mismatched columns. Now we're encountering an issue, not one that I got earlier, but we're gonna cancel this out. We're gonna figure this out together. So let's print off our individual row data. Let's look at this. This one is empty. This is, I'm almost certain, is probably the issue. I didn't encounter this issue when I wrote these, when I wrote this lesson, but I'm almost certain that this is the issue right here. So let's do the column data, but let's start at position. Let's try 1 and not parentheses. I need brackets because this is a list, right? So it should work. And there we go. So now that first one's gone. So now we just have the information. I didn't even think about that just a second ago, but I'm glad we're running into it in case you ran into that issue. Let's go ahead and try this again. And it looked like it worked. So let's pull our data frame down. I could have just wrote DF. Let's pull our data frame down. And now this is looking fantastic. Now, these 3 dots just mean there's information in there, just doesn't want to display it. But it looks like we have our rank, we have our name, we have the industry, revenue growth, employees, and headquarters for every single one. So this is perfect. Now, this is exactly what I was hoping to get. Now you can go in and use pandas and manipulate this and change it and dive into all the information in there. But we can also export this into a CSV if that's what you're wanting. So we could easily do that by saying, we'll do df.to_CSV. And then within here, we're just going to do R and specify our file path. So let's come down here to our file path. Then we'll go to our folder for our output. So we're just going to take this path and let me do it like that. So I have this path in my OneDrive documents, Python web scraping folder for output. So, I already made this. And I'm just going to put this right down here. Now I do have to specify what we're going to call this. We'll just call this companies. And then we have to say .csv. That is very important. Now, if we run this, I already know just because we have this rank and this index here, we're going to keep this index in the output. Not great, but let's run it. Let's look at our output. There's our companies. And when we pull this up, as you can see, this is not what we want because we have this extra thing right here. Now, if we're automating this, this would get super annoying. So what we're going to do is go back and just say index equals false. Let's go out of here. And now we're just going to come right down here. We're going to say comma index equals false. And so it's going to take this index and it's not going to import or actually export it into the CSV. Now let's go ahead and run this. Let's pull up our folder one more time. And let's refresh just to make sure. Should be good. And now this looks a lot better. So we're able to take all of that information and put it into a CSV and it's all there. So this is the whole project. So if we scroll all the way back up, let's just kind of glance at what we did here. Scroll down. We brought in our libraries and packages. We specified our URL, we brought in our soup, and then we tried to find our table. Now that took a little bit of testing out, but we knew that the table was the second one, so in position 1. So we took that table. We were also able to specify it using find, but then we used the class. And of course, we just wanted to work with that table. That's all the data we wanted. So we specified this is our table. And we worked with just our table going forward. Of course, we encountered some small issues, user errors on my end, but we were able to get our world titles and we put those into our data frame right here using pandas. Then next, we went back and we got all the row data and the individual data from those rows, and we put it into our pandas data frame. Then we came below and we exported this into an actual CSV file. So that is how we can use web scraping to get data from something like a table and put it into a pandas data frame. I hope that this lesson was helpful. I know we encountered some issues. That's on my end and I apologize. But if you run into the same issues, hopefully that helped. But I hope this was helpful. And if you like this, be sure to like and subscribe below. I appreciate you. I love you. And I will see you in the next lesson.